Test.
Yeah, what I did.
Oh, oh,
I thought it was going to be your login. Set up for other.
sure.
Okay, got it.
Oh, that one.
Yeah.
Can y'all hear me? My name is Shelley Pridgeon, and I'm with the Research Division at TxDOT, and we're here today for the ninth STIC meeting. And I know that several of y'all have attended these in the past, and I hope that today that you'll enjoy what we have planned for you. And I'm going to start with Darren. He's going to have some welcoming comments. He's going to come on up here. Thank you, Darren. Please help me and welcome Darren Anderson.
All right, thanks. Thanks for being here today. I know we're all very busy and have a lot to work on, and so I hope that this continues to be of value to you. We've been talking a lot about how we continue to make or bring presentations or information that is useful, and I'm very excited about some of the work that we've begun doing with the LTAP program and how we are looking forward to bringing state level and national level research out to all parts of Texas and not just focus at the state level. And so, if anything, that's been one of the greatest benefits of having the STIC meetings is that we've learned that that's an avenue that had been untapped. And so I'm really excited about the opportunity to do that. Lots going on this month for me and for TxDOT and Futures efforts. We had the Texas Mobility Summit in San Antonio a few weeks ago. If you're not familiar with that, that's a compilation of a number of city and regional teams that are focused on transportation and technology challenges related to transportation that support their people or their region and their concerns. And TxDOT helps facilitate that by bringing together that group, at least on an annual basis, and then through regular phone calls or telecons to talk about those and find ways that we can bring solutions to particular problems and get the right industry folks and the right academic research to bear on those efforts. And then as it pans out, if the solutions are viable and useful, then to scale that more broadly across the state where a similar challenge might exist in another region or city. And that is generally a new idea, and really only Texas is doing it. I constantly get feedback as I go to different national forums about how amazing it is that we've been able to keep the alliance going and keep the members working together as opposed to competing with each other for federal grants or competing to always be the premier city. And certainly they want to still be that, but it also brings a much broader scale to some of those efforts. And so very pleased with that and very appreciative of the city of San Antonio for hosting it this year. And next year it looks like El Paso will do it, which is kind of cool. We'll get to go out to the west. I was in Iowa at the beginning of this week at an AASHTO, that's the Association of State Highway Transportation Organizations. AASHTO has a committee that's looking at should there be a national strategy for highway automation. And they may change some of the language of even the name of the strategy because they realize that's highway focused and they realize that it might not touch on all the things that they're concerned about. But the good news is that they are talking about it. They realize that something needs to be done in terms of commonality between states, especially as it relates to freight movement, but also passenger vehicles as well. And we didn't solve the world's challenges in 2 days, but we got things started, which was really nice. And I think that they've gone back with food for thought and things that they can begin to put together. And we can then go out to a much broader part of AASHTO, and as well as there were a number of partners there, ITS America, who else? IEEE, and just the myriad of associations and organizations that have a play in the transportation field, especially the technology component, had at least a representative there. So that was very beneficial. And then I flew back and went to San Antonio this morning and spoke to the Texas Freight Advisory Committee. Had a panel. Actually, I didn't speak. I had a panel that they asked me to put together to make them aware of emerging technology and research related to the freight industry that they should be tracking on and have visibility of when it might be coming to fruition. And really, could have probably spent the whole day as opposed to 1 hour answering questions once we started telling them some of the information we had. So that was great. And now, drove up here, and here I am. It's been a very positive increase in interest in where the future of transportation is going, and this is a key aspect of that, is bringing the research that's leading that effort into Texas and into all the regions and cities and counties of Texas. And I will be going to many other places in the near future as a part of our Connected Autonomous Vehicles State Task Force to begin to educate and inform at multiple levels, all levels of political leadership as well as the public, about what's the current state of that technology or those technologies and what they mean, and are they safe, and are they cyber secure, and all the major concerns, and will they displace jobs and things like that. And I think that's really the value that efforts like this and that bring to what we do at TxDOT is not necessarily being the ones that solve it all, but making sure that everybody understands where we are and where we're going. When I say we, a lot of times that's where is industry going, so that we understand what they're thinking and then how we are a partner to that, not just reactionary to it. And I think that's key, is not being reactionary. I really appreciate y'all being here today. Al is tied up in some of his kids' events this week. Unfortunately, I hear that maybe his son may not be able to play because he got injured. But you know, he sends his regards as well. I mean, you have any things you want to pass on? And with that, rather than me talking all morning, let's get started. Or afternoon.
Okay, well, yesterday and today, so the 4th and the 5th, we had a nice little workshop going on here in the same room, and we learned a lot about value capture. And today, Rafael Aldrete will come and give us a quick review of the things that we went over, maybe some of the takeaways, just to give us an idea of what we all learned in the past 2 days.
Thank you, Shelley. Well, like Shelley mentioned, over the last 2 days, we had a 1.5-day workshop sponsored by Federal Highway and TxDOT. It was part of the Federal Highway Administration's Every Day Counts 5 initiative, and this part of the EDC 5 initiative is aimed at promoting the use of value capture strategies to state, local, and MPOs, state, local governments, and MPOs. So the workshop, we had about 75 people registered. We actually got 50 yesterday when we opened the sessions. It was very productive. We had a lot of discussion. The presentations that we had covered different concepts of around value capture. And value capture, what it is it's a set of tools and techniques that allows transportation municipalities and other agencies to take advantage of the increased economic activity, increased growth, increased development, to use that additional property tax revenue, for example, to help pay for the transportation improvements. And we saw different techniques. We had an overview of all the 8 types of techniques that Federal Highway is promoting. And then we have peers from throughout the state and from other states, from Arizona, talking to us about specific examples and case studies on, here for Texas, we had TxDOT presenting about transportation reinvestment zones at the state level, but we also had an example of a small municipality that has taken advantage of this TRC tool for transportation funding. We also had presentations on something called joint development, impact fees, traffic impact fees, and in sales tax districts that are used in other states. And those are some of the tools of which we had direct experiences from people who have implemented those projects. So towards the end of the workshop, one of the aims that Federal Highway had for this peer exchange was to help get some ideas for the next year work plan on how they will continue to foster or promote the implementation or the use of these value capture tools. So some of the feedback that we got from the participants today was to increase the availability of tools for local municipalities, MPOs, to educate their policymakers, educate the city council members, their transportation policy board members, and the private sector. And it was very clear that most of these value capture innovative financing tools fall within the realm of the local government. So it's really important to provide them with the tools they need in order to increase awareness about the set of tools. So Federal Highway is going to be putting together the work plan for the program next year, and they're going to be looking at possibly developing some of these tools like briefing books and short, concise infographics and other material that they can use to brief their policymakers in a quick and effective manner. And with that, we closed the workshop a few minutes ago, and I think everybody found it very productive. Thank you.
Thank you, Rafael, for that update. I feel like the value capture peer exchange was a good example of corroboration between different entities. I actually participated in most of it, and I enjoyed hearing everyone's discussions. So it was a good thing. And Kirk Favre had a big hand in getting that together. So now I'd like to introduce someone that I actually know from some work with the NCT COG. Back when I was at the Dallas district, I was able to be the bicycle coordinator for the district, and so I participated in what they call the BPAC. And Millie has had a lot of presentations, and she's been very helpful in providing information to different entities throughout that area in that region. So let me welcome Millie Hayes, and she's going to talk about crowdsourcing, which we all know is a pretty big topic right now, you know, with Waze and other types of methods. And I'm going to let her tell you about that.
Thank you, Shelly. Can everyone hear me okay? Okay, perfect. Sorry, it should be right here. So if you go, see, try this. Go down. Uh-oh. Darn, I thought we were okay. Let's do this. Or, I need you. It's your laptop.
That's a great parenting. It weighs about 65 pounds.
Dawn is projecting. She sent you that presentation. So she just sent it. I'd have to call James Core up here, our WebEx guru. So you can't join. All right. That's it. We're good. So we just have to project. Okay, guys. Crisis averted. As soon as it catches up. Projected. Do I need to extend your display? Why is it not coming up? Yeah, we just need to. It's just this one. It's just. Thank you for your patience. Back to Millie.
Thanks, folks. As some of you in the audience might know, I don't know how to turn on my own TV, so like this is right along my alley. I'm Millie Hayes, and like Shelly said, I'm with Federal Highway Administration here in Austin, and I am a safety and traffic operations specialist. So if you know Steve Ratke, he and I have very similar jobs, and then there's also Ed Burgos Gomez of our office who also works on safety. So we're tag teaming 3 different people. So I am the one here in Texas who's spearheading the crowdsourcing for operations. So as a refresher, EDC, I'm sure everyone knows what it is, but just in case, we'll review. EDC is a state-based model to identify and rapidly deploy proven but underutilized innovations. So this year, 2019, FHWA announced the 5th round of the EDC program. This offered 10 new innovations to improve highway safety, reduce congestion and promote environmental sustainability. Crowdsourcing for operations is just one of those 10 innovations, but it really overlaps and collaborates with these 2 other innovations that are on the screen. Our overall crowdsourcing for operations goal is to increase the number of agencies that use crowdsourcing to better operate the transportation system as a whole through new, cost-effective, and proactive operational strategies and applications. So as the program name states, the focus of this EDC is on operations. So what do we mean by operations? Operations is not new. I know TSMO is up there on the screen. If you have been here for a couple decades, you might know the term IVHS, more recently ITS, and then currently TSMO. And so if you're TxDOT or partner often with TxDOT, this slide on TSMO will probably be very familiar to you because, as you may know, TxDOT has been doing quite a bit with TSMO in the last 2 years. So the concept of IVHS, ITS, and TSMO is really all the same. It's optimizing the performance of infrastructure and really treating our capacity as an asset that can be managed. So the key foundation is to effectively operate the system. And in order to do that, first we need to know its current status in real time. So that means that you have to monitor and have real-time awareness of the system. And once you have that, you can then assess the performance of the system and implement dynamic actions and prevent or delay the onset of congestion. Real-time monitoring is really the backbone of operations. So for many agencies, it's kind of our Achilles heels, and we might not even realize that. So why is that? There's 4 different limitations that are on the screen. First, the field equipment like our roadside sensors, our CCTV, our DMS are really costly to acquire and maintain. So this results in significant gaps in geographic coverage. Sometimes there's inconsistent functioning. Not everything works 100% of the time. For example, freeways are often monitored at maybe half-a-mile intervals in our urban areas, and then maybe more sporadically in our rural regions, and maybe sometimes not at all in a lot of our arterial systems. So lags also require us to act in reactive or catch-up mode instead of being proactive. An example of that would be notification of an incident will come into the 911 dispatch center. So the dispatcher will then enter that incident into the CAD system, the police department CAD system, and then transfer that information to our traffic management center. And then in the TMC, the operator is verifying using our cameras to make sure that does that incident actually exist. So all of that takes time. And this time that is spent increases the likelihood of secondary incidents, and more congestion continues to develop. Finally, there are data stovepipes. So that could be either within jurisdictions or across jurisdictions. So even in some of our advanced TMCs, if something happens on a parallel arterial, sometimes the DOT doesn't find out until congestion hits the freeway. And by then it's often too late to do much for a response. So all of these challenges prevent agencies from operating at their full potential. Fortunately, we're in a new and exciting time to be in operations. Agencies are now realizing the importance of operations, and states like us here in Texas and other states are ramping up our TSMO programs and our processes. So at the same time, we have advances in technology that are changing the way that we operate. So obviously the internet, big data, support systems like machine learning, and our cloud-based systems. Crowdsourcing is one of those transformational technologies that can help agencies radically improve their geographic coverage, the timeliness of their data feeds, and overcome jurisdictional and data stovepipes. This all leads to more effective operation strategies. An example would be one of our sample communities had observed, they had been tracking their incident detection times, and they were able to speed up, to reduce their incident detection time by 10 minutes, which is huge if you have ever worked in a TMC or know folks who have. So this is a huge advantage for agencies to respond to incidents and to help mitigate our congestion-causing events, therefore improving safety. So what exactly is crowdsourcing? It's addressing a problem by enlisting the services of a large number of people via technologies. So it outsources our tasks beyond an organization's means and beyond what resources you might already have on your own. It leverages collective wisdom of a diverse crowd, and it requires technology to communicate all of that data. So does anyone here, it's not on anymore, but did anyone here watch Who Wants to Be a Millionaire, the show on TV? Is everyone embarrassed to like say that they watched it? I used to watch it. So do you remember the lifelines, specifically the Ask the Audience lifeline? Okay. So how often do you think the audience was right? Whoa, someone watched the Federal Highway webinar. It's surprisingly, I was shocked to see this. It was 95%. To compare, the Phone a Friend only had success rates in the 60%, which to me, I was fascinated to hear. Really, that is an example of leveraging the larger group as a whole. So crowdsourcing isn't new. The example, the first one on the screen with the cow next to it, over 100 years ago, there was a British scientist who capitalized on a diverse crowd. And it was in order to guess the weight of a cow. The crowdsourcing data was actually only 2 pounds off of the actual weight of the cow. And the wisdom of the collective crowd was obviously more accurate than any one estimate. Something more closer to home would be Amazon. Before they started selling everything else, Amazon just sold the books. This example was using machine learning to weight the reviews based on user trust and other factors. That all started in 2004 when they were realizing that people were tampering with the reviews and kind of trying to leverage it for their own positive good of their own items. And so they ended up putting in some checks and balances into the system in order to make it a little bit more accurate. So there's many other examples of crowdsourcing. So here are some folks on the slide who have used crowdsourcing. As you can see, it's public agencies, it's private agencies, and a lot of these are incentivizing the crowd, and like with the Amazon example, managing the good and the bad within that crowd, and it's proven to be effective. So bringing it back to transportation, in transportation there are 3 different means for crowdsourcing. So first, there's data extracted from social media platforms. So that would be your Twitters and your Facebooks, etc. These often escalate during major events, especially weather events. Second, there's data acquired from third-party data aggregators. And third, there's data acquired from mobile apps that are specifically developed for the transportation system. So in terms of the types of data that can be accessed via crowdsourcing, there are both quantitative and qualitative types of data. So an example would be probe data from cell tower triangulation. And this could be processed by a third-party provider to deliver data for speed or travel time data. This is different than a Twitter feed, which would offer text-based data that should be analyzed differently to support decision-making. So the jelly beans on the screen are supposed to convey how different data can be consistent, while others may offer a mix of quantitative and qualitative data. So how does all of this help operations? Here are the application areas for crowdsourcing for operations. So this recognizes that crowdsourcing data is one of just a number of sources of data that supports transportation operations. So like other sources of data, crowdsourcing data can improve your interconnected operational programs for traveler information and for traffic incident management. Also can improve arterial management and also work zone management. Agencies are also using crowdsourced data to support performance assessment and some of their reporting functions. So here are some examples of some specific benefits. We already kind of touched on the transportation operations benefits, but I really wanted to point out the benefits besides just those ones that we would typically think of that are on the bottom half of the screen. So really you can have benefits besides just transportation-specific benefits, including improved transparency and really getting the public to feel like they have an opportunity to contribute in your system and in the management of it. So next I'll go through briefly just 5 examples that we have showcasing throughout the country. So the first is in Louisville, and Louisville has been leveraging crowdsourcing for some time for a number of different civic-focused purposes. They initially started using it to map local internet service quality, and then they used it for citizen feedback for a corridor revamping, and they're continuing to try to grow their applications for crowdsourcing. So specific to operations, they've been pushing real-time road closure data to a variety of different navigation apps to help improve routing around special events. And Louisville has also eliminated the time-consuming effort of travel time runs after they've done signal retiming. So instead they use the Power BI software just by clicking a few buttons to comb through Waze data archives, and this determines whether or not their traffic signal retiming was effective. So obviously this saves a lot of resources and a lot of time and gives you a lot more data than simply a few travel time runs. The next example is Port Authority of New York and New Jersey. And so they share their construction and detour and incident information with different navigation platforms to affect routing choices. And they also pull data from Waze, Here, and others to help manage the region. So this is an example of application of crowdsourcing for traveler information, traffic incident management, arterial management, and work zone management used all at once. The next example is Indiana DOT, which purchases third-party probe data to actively manage traffic on major highways and corridors of interest. So one of their specific examples of using crowdsourcing was an unplanned bridge closure along I-65 that required a detour. On the first day, the detour took nearly 4 hours to navigate, and using the probe data, they were able to quickly identify and mitigate the causes of delay through the corridor. So they quickly installed signalization at areas that had previously just 4-way stops. They placed mobile message signs and did a whole bunch of other things. Within 5 days, the travel time was stabilized to about an hour. So the heat map on the bottom of the screen shows in pink the number of miles where the speed was below 15 miles per hour. Another thing that they're doing is working with Purdue University, and they created a traffic ticker tool. And that is where TMC operators, they identify locations that might need attention. And so the image that's on the right side of the screen shows the use of the tool to support training of the operators and for after-action reviews at the TMC. The next example is Utah's Citizen Report Program, which is a really good example of crowdsourcing data collected from a specifically developed mobile app. So if you've been to Utah, especially in the winter, you know that certain passes over the mountains may quickly turn from drivable to completely impassable. So through this app, the Utah DOT enlisted nearly 1,000 citizen reporters who had been specifically trained to provide road weather data. The DOT developed a method to identify inaccurate reports and preclude their future consideration, so it's kind of like those Amazon reviews. They also have a process that weights differently the different sources of information. So the information that's coming in from their snowplows that are DOT owned are given priority. And then there's also a mix of meteorological reporting and citizen reporting that's based on really the age of the data because they want it to be the most current. So the blended and the cleaned up data provides information on for travelers to make a safe and efficient commute decision. My last example is from Delaware DOT, which has a very similar state-developed app, and they use that for traveler information and event and road weather reporting. So overall, across the country through federal highways, the goal for crowdsourcing for operations is to increase the number of agencies that use crowdsourcing. So states are at many different levels of capability maturity in terms of what crowdsourcing data they collect, how they manage the data, how they integrate the data with other more traditional data like your camera data or your roadway sensors, and then also how you're using it just overall. So over 30 states selected this innovation in this last round for EDC 5, and the map shows the level of capability maturity for each state, and that's a self-selected baseline. Obviously you can see Texas is on there, that we selected demonstration, and I'll talk more about that on the next slide. So states set their own goals on how to improve in crowdsourcing. So the goals may vary. Some states had goals specifically to just acquire crowdsourcing data streams. Some are testing the accuracy of a crowdsourcing provider. Some are filtering the data and figuring out how to do that better. Some are trying to figure out how to automate the integration of the data. And some are even trying to automate the entire workflow using the data. This table shows all of the states, and I'll point to Texas, which is like smack dab in the middle. So just focus on Texas because the graph is a little bit hard to follow. Texas baseline is currently at demonstration, which is pretty middle of the road. And the Texas goal is assessment. So this is advancing one stage, and that is what we call the jump to make an advance in one stage in any application. So in terms of what we're currently doing now, I do have a few really neat local examples. Most locally here in City of Austin, crowdsourcing data had been used to evaluate effectiveness of the signal timing, so kind of like what Louisville was doing. And then also in NCT COGS area, there's a collaboration between the COGS Transportation Department and the 911 Department to get Waze incident data streamed into over 40 911 centers across the region. So I know there are other examples, those are just ones that I wanted to point out that were very different. So these are some of the resources that we have developed to help states achieve their goals in implementing crowdsourced data. So there was a November 5th webinar, obviously that already passed, but the recording is on the National Operations Center of Excellence website, and I highly recommend looking at that one if you haven't already. And the one that's on here for vendor engagement is actually like literally right now. So you're missing it, but I believe it's being recorded as well, so recommend looking at that one too. And then there will be another one in January. I don't believe the date has been announced yet. So we also have options to do workshops in any specific state, and we have some sample agendas here in the Texas Division office if that is of interest. And FHWA is also conducting peer exchanges. The first one is taking place next week in Nashville, Tennessee, and the focus will be on lessons learned and the validation and filtering of free crowdsourced data. So FHWA is also, in general, able to provide on-site technical assistance, training, and case study information, so we're happy to do that at any time. So James and Paul on the screen are our national experts, go-to people nationally for crowdsourcing. And then I am the local person, so feel free to contact if we can help in any way. And I didn't put it on the previous screen, but the EDC website, which you're probably very familiar with, has a lot of different documents on there, including the fact sheet that's about 2 pages, and I have some at my table over here, and then some Q&A documents as well. So highly recommend looking at all of those. But with that, if you have some questions, let me know.
The workshops open to all elements? Is there any kind of who gets to go to workshops and not?
I think we'd be able to accommodate whoever you felt would be needed there.
And
Pretty flexible with the workshops. We're able to fit your specific needs. So.
And Millie, correct me if I'm wrong, a lot of times Federal Highway can pay for 1 or 2 from each state to go to some of these peer exchanges in those workshops. So, Darren, I think if we have a couple folks in mind.
And has TxDOT asked for a workshop?
For crowdsourcing,
Mhm.
I do not believe y'all have.
Okay. Can you speak to have any of those examples, have they talked to the challenges that they've had with making it work?
There were some. I had seen a couple couple slides, and I think it was on one of the Q&A, it's like a 6-page document, that had some specific things to take into consideration, and I believe that was from different case studies that James and Paul had gathered together. But I can track that down for us.
Yeah, I mean, we've pursued working with Waze for actually many years, and we're a connected citizen agreement with them for the state, and we know that multiple cities in the state are in the same agreement with them. And the challenge we've had, I mean, this goes all the way back to Hurricane Harvey. At the time, we had not signed on with them, but that's really just a piece of paper. It's not that, it doesn't mean a whole lot. And we were more than willing to open up Drive Texas data to them so that they had real-time information about flooding on the system. But what we found over time is we've really struggled with them on formatting. That we could not just establish an API and say, our data's here, here's how it's constructed, and you can go to this API and consume it. They wanted us to take our data and format it into their formats, or they weren't going to use it. And that's continued. I mean, we're really still in the infancy of sharing data with them, which is a source of frustration for me. And I imagine, since Google is now the parent company for them, that Google Maps is not much different. And I would guess the same for Apple. But that API does exist, and it is being used by federal agencies and state agencies during, especially during emergency weather events. So we know that it's effective in its ability to share data, and we certainly believe things like construction zones and weather-related issues and other anomalies on a system are of value. And the more we can share them out, the great, because then we know that citizens are getting their information multiple ways now as it relates to the traffic situation. And we really hope that we can get to the point where we're being fed data too that's data that we don't know. Right now we're more of a air gap, one screen beside another, and looking at what they're reporting and then going and validating ourselves. But if y'all can help us move that forward, I'm more than willing to do that. And I will encourage Traffic Division to reach out and see if we can't get a workshop going. Part of the challenge is just like in here, who else needs to know? And many times they just don't know that this is out there and available to them. And then you mentioned the apps. We've always been on the fence on whether or not TxDOT should build any apps, because we find that the third-party providers are, like Waze, are much faster and much more able to do it than ours. So I'm really interested that Delaware and the other state had built one. And maybe we'll look into adopting that, and I'll talk to the CIO about it. But, I mean, I do see a lot of value if we recognize that the traffic management environment is so much greater now than just the public doing, the government part of the public doing it. And rather than ignoring it, we need to a degree, embrace it and realize that in a shared environment that we'll probably get more, accurate data and more rapidly share that if we acknowledge that those guys are out there doing the same. Flip side of it, though, they give different traffic movement solutions or mobility solutions than we do. So, the bigger question I think we'll have to research over time is, if you have multiple sources of information for traffic management, are they conflicting with each other and ultimately not contributing to a greater optimization of the system? That's my thoughts.
Millie, I can add a little bit about what because we've actually incorporated Waze data into the 911 dispatch centers, but we've also incorporated it into our 511 DFW system. And the biggest challenge that we have is weeding through the data. There's so much of it that comes through Waze, and what we had to do is filter some of the items out that were related more to traffic operations, just because it would overwhelm your map with information out there. We were able to work with Waze too to share data with them, but the biggest challenge is the amount of data and being able to analyze it and kind of organize it so you can make sense out of the data that you have. I think that's one of the biggest challenges with some of this data that we're getting. We also get data from a third-party vendor. Here, we get data for our speeds on our 511 DFW system, and we have a performance measures background module that allows us to analyze before and after analysis on roadway improvements, whether that's arterials or freeways, managed lanes, things to that sort. So we do have a tool that allows us to kind of quantify the benefits a little bit more than us trying to go through a manual process to do that. And we kind of question the same thing. We have a 511 DFW app, but at what point do we not maintain that app? We just share that data with the third party or those private sector partners because, I mean, granted, they're better at doing some of this stuff than we are, and maybe we spend our money on the back end of how do we integrate the operation of our system for our public sector partners, and we can better operate the system we have and let them feed the information to the public. We have an interactive voice recording as part of 511 too, and it's really expensive to maintain, and at what point do we not do that anymore? These are questions that I think are valid to ask, and we just have to work through them as public sector agencies.
I think in terms of especially regions here in Texas, I know y'all have done the most with the 511, especially integrating ways. So highly recommend if folks are struggling, especially at the beginning. It seems like y'all had figured it out really well. Maybe it took a ton of time to get there. I don't know, but I'm just seeing it at the end result, which has been amazing.
Well, and two, I mean, I mentioned the workshop, I mean, but the peer, I mean, TxDOT or Texas as a whole could have its own peer exchange just because of the number and volume of cities and regions that could be brought into that. So, you know, I really think that, you know, maybe we could work that and tie that into the Innovation Alliance, because that's where, you know, a large number of our cities are already represented. And maybe we just do our own and really take some of the lessons from the other states and get to the point where we're actually solving some more of the challenge, you know, really, I won't say leap yet, but you know, push that jump to the limits that we can get to.
Yeah, that sounds like a great idea. Just to do maybe look into a state-specific peer exchange, because it seems like every meeting I'm at, someone else is talking about incorporating Waze data or other, you know, similar, and I think folks are doing it, and maybe we need to just get them all in a room. I saw a hand. Yes.
Is anyone doing anything to try to standardize this whole process across the country?
I think that would be our national folks, trying to get people to be consistent.
Because each state could do its own.
Right. Well, I'm here all afternoon, so holler if you have questions.
Thank you, Millie. That was great. Thank you also for going over the Everyday Counts initiatives and explaining that to everyone. Since we're running a little bit ahead of schedule, I wanted to do a quick, just sort of go around the front table and have the committee members introduce themselves and say where you're from, if you don't mind. And we can start with this gentleman over here. Oh, is it working?
There we go. My name is Brandon Hicks. I'm representing Harris County Engineering Department. I'm the manager of the Transportation and Planning Division.
My name is Tiffany Reed Villarreal, and I'm the Vice President for American Society of Civil Engineers in Texas.
I'm Mark Jacobson, and I'm with the City of San Antonio, and I'm representing the Texas District of the Institute of Transportation Engineers. I'm their current Vice President.
I'm Natalie Bedker. I'm with the North Central Texas Council of Governments. I oversee congestion and operations systems, and I'm a senior program manager.
Tony Voigt, I'm a past president and current administrator for ITS Texas.
Marcus Wilner, I'm with Federal Highway Administration here in Texas, Chief Operating Officer.
Darren Anderson, Director of Strategy and Innovation at TxDOT, and I apologize, I was supposed to do this when I did the intro.
Don't worry about it.
Kirk Favre, Federal Highway Administration, Texas Division. I'm do planning and research. I have oversight of the stick and everyday counts.
David Palmer, Texas Department of Public Safety, Texas Highway Patrol, Major.
Jeff Daly, Deputy Executive Director, Central Texas Regional Mobility Authority. I'm here on behalf of Mike Halligenstein, the Executive Director.
I'm Joe Trammell with Tarrant County, County Engineer, but I'm here on representing the Texas Association of County Engineers.
Philip Hempel with the Texas Department of Transportation Research Division.
And I'm Kevin Pete. I'm the Director of the Research and Technology Implementation Division.
I appreciate all of y'all introducing yourselves. And I apologize, I was in a hurry at the beginning to get someone in and out of here. And thank y'all for accommodating that and other technical difficulties. But the good news is this is a robust schedule, and this agenda is actually very good, and I hope that you really enjoy what we have to talk about today. We have a few more really good projects that are innovative, and I think that you'll appreciate them. Some you may have heard of before, and they're all everyday counts initiatives. And some of the people we have here have been talking about things from, weather to traffic signal performance, and I think you're going to enjoy what they have to say. But let me just give you a quick note that after these next three presenters, which are our everyday counts updates, we will have a break. And just so you know, the restrooms are located down the hall this way to your left when you walk out these doors, or if you cannot go there for some reason, there's also a restroom facility down through the pool house to the right that way. And emergency exits, as you note, are anywhere in this room, and then you can go out the front lobby. And if y'all have any questions, we have staff, we have AV staff around, and they can be of help to you. Without further ado, I would like to call Ken Perrine with the Center for Transportation Research, and he's going to talk about weather responsive management strategies.
Thank you, and thank you for the opportunity to present with you this afternoon. So on the Weather Responsive Management Strategies project, we have a variety of participants with TxDOT that I'm very grateful for. Our project manager, Wade Odell, and our advisors, Dan Richardson up in the Abilene district, and John Navarez here in the Austin district, also David McDonald, and also our faculty and students who are working on this at the University of Texas, including 2 PhD students. Within the EDC5 Weather Responsive Management Strategies initiative, there are 2 main themes, one of which is to develop new capabilities and also to increase the effectiveness and reduce costs. And one component of that really feeds into what Millie just talked about, which is being able to really fold in information and feedback from the traveling public. So how are we doing it within the project? What are we intending to do? What we want to do is implement a small-scale weather responsive management strategy within a chosen area of Texas. In this case, we choose to look at winter weather, and we're looking at the Abilene district. I'll talk more about the characteristics of that district, and be able to see how many of the objectives we can actually reach that the initiative is reaching out towards. With that, we also want to become more familiar with the technologies and data sources that are available so that we might be able to understand them better and understand their applicability to other regions within TxDOT. The location, as I mentioned, is Abilene, Texas, about 3 hours west of Dallas-Fort Worth. A population that's modest for Texas, and a very interesting proving ground for this because they have winter weather. And they also have an urban center, but they also have a lot of rural regions. You'll notice in this picture that this obviously is not central Austin, but yet there are enough vehicles and travelers within the region, both local and also a lot of travelers on Interstate 20 that are passing through that becomes a very high priority to be able to keep that region operating smoothly when there's times of extreme weather. Within our management strategy, we're creating a data framework. We're incorporating different data sources into already existing Lone Star infrastructure, the active traffic management system used by several TxDOT districts, but also incorporating our own operational platform off to the side that allows us to prove concepts. We're intending to have both of these appear within the Traffic Operations Center so that the operators can really use the data sources in one unique, unified location. The two different data sources that are in bold on the left side, the weather stations and the on-vehicle road surface characterization devices, are devices that we're intending to purchase through the project, but there are also a variety of different data sources that are already available, including regional weather and predictions by the National Weather Service. And again, going along with what Millie had said, I think there's two other bullet points that really belong there, one of which is an initiative that I've found out that is going on with National Weather Service called COCOROS, which is a crowdsourced weather reporting service that has actually a data infrastructure, and also Waze data. With that also is the statewide efforts for creating and providing real-time speed data within Lone Star. What we want to do with the project is to look across the nation and see what other best practices are being done. At the Road Weather Management Stakeholder Meeting in Phoenix back in August, I learned a lot about what other DOTs are doing, and different DOTs across the country have their own unique needs in their various jurisdictions, but they are also at all areas across the map as far as implementation. Some are very excited about plow cams on their snow plows so people can see where the plows are, but others are really working toward a fully integrated system that has cost millions and millions of dollars to implement. We want to understand what they're doing and understand how can we leverage what they're doing here in Texas in a very cost-effective manner. We also want to integrate with as much infrastructure that already exists here in Texas, getting up and running with Lone Star as much as we can. Currently, Lone Star is used in the Abilene district, but it's only used to operate their DMS signs, their dynamic messaging signs. We want to up that and be able to integrate speed data into Lone Star and also be able to have our weather sensors appear within Lone Star. We also want to have a good balance between implementation and research sort of activities that can really be beneficial in the future, including looking at historic data and using machine learning to predict best operational practices for the future given current data sources. There's a variety of challenges that we encounter along the way, and these are challenges that continue on from the previous phase of the project in the ED4 portion, which is working with real sensors has a lot of potential delays from vendors, also challenges in being able to understand how sensors work, making the data work together so that we can feed data into the appropriate locations. All of these are things that we're looking at in this project, and we want to be able to report upon them so that the job is much easier in the future. Our schedule for this phase of the project, the EDC 5 portion, has begun in May and will be going through May 2021. And through that, we have 2 winter seasons that we can be on the road collecting data and testing out our roadway information systems and weather responsive management strategy implementation and demonstrations. Right now, we're in the process of deploying a few different sensors just to collect data off of them. And we're gearing up over the next year to build up that demonstration platform so that we can put it out in the field within the Abilene district for the next winter season. With that, we have an upcoming site visit up to Abilene to deploy a couple sensing technologies, in particular weather stations. And we're also working with them on being able to really fit into their operational practices as much as possible. While they're excited about the idea of new data sources appearing within their operations center, they also don't want to be spending a lot of time on trying to adopt new technologies that haven't been proven yet. So we have to reach a very equitable balance when we're talking about incorporating these new sensing technologies within the existing environment. And that's something that's always an active area of conversation. I thank you very much and invite any questions that you have.
I have a quick question. What is the device, you're putting devices on the vehicles, like maintenance vehicles, or are you putting them on just the snowplow vehicles to detect road conditions? Is that correct?
To be determined.
Oh.
So we had one such device put on it's basically just a fleet vehicle, a pickup truck, that's used to go diagnose different areas of the region for ice conditions on the roadway and all kinds of other activities. It's the mobile eyesight, and it characterizes road surface temperature and road surface characterization. It would say whether there's ice on the road or slush. And even though in the ideal situation we'd have one of these on each vehicle, the reality is that they're very expensive. So we still need to work in a very small scale and try to understand as much as we can from that small scale, what are the potentials for that technology.
Yeah, that's what I was going to ask, how expensive it is, because some roving vehicles, like our courtesy patrol or mobility assistance patrol vehicles, might be perfect vehicles to put this type of technology on if it's cost effective.
Yes, I'm really glad you mentioned that, because we have actually been in conversation with John Navarez and Adam Kalzewski with Austin District about putting one of those on a Hero vehicle. And that's an excellent vehicle because the Hero vehicles go all around the highway infrastructure within this region and would collect wonderful data on roadway conditions, especially when there's freezing weather setting in.
So we're definitely interested in learning more about that technology when you get additional information.
Great.
I had a question. I was just curious about how, what kind of thought about you get this weather stations, the
Yes.
fixed ones, versus if you start implementing these mobile ones, what's the thought about a system and how that would affect things? Whether you still need them or not?
Right. Well, we have a lot of data sources, but in talking with the folks up in Abilene, they have their National Weather Service sources, which there's one at the airport, there's one about 100 miles away. They really want to know what's happening at the roadway. So they want additional sensors to fill in the gaps because they know their problem spots, and they would much prefer to be able to look at a dashboard online in their operations center and see exactly what's going on there rather than sending somebody out there or trying to discern from their weather maps what might be happening in that region. They really do say that within a 20-mile radius, the weather conditions can be very different, especially when there's precipitation. So that's one of the reasons why they're interested in these smaller scale stations. And if we can also incorporate additional data sources such as crowdsourced observations, I think it would even be better. But they're also very interested in the idea of these fixed stations because they know exactly where it is. If they have mobile stations, there's always the question of, is the sensor in the right place at the right time? And I think that's an ongoing research question that we're going to be very interested in addressing, is how to best address this mobile data that could be in one location at one time and another location at another time to actually create a complete picture of the whole region.
All right, thank you. Yeah, we're looking at installing some on our roadway systems, the weather stations as well. So this is interesting about the mobile units.
Okay, so like Natalie, we better be in contact then.
Yes, sir.
Ken, you mentioned use of crowdsourced data in your presentation. Is that part of your research, or is that something that's next down the line sometime?
In our literature survey, both in the EDC4 portion and the EDC5 portion, we've looked into that. We have not made accommodation for specifically looking at that, but I think with this emphasis, I am reminded once again that we're always flexible for adjusting to where the needs are, and I think it is something that I do want to emphasize more as we progress. Just seeing how accessible crowdsourced data would be, especially if TxDOT really is able to integrate Waze data more into various districts. I think this would be very valuable and very relevant.
just one other thought, and I'd have to dig into, but I know a couple of years ago, I think it was Wisconsin, we signed an agreement with them to get their kernel for video sharing off of their plows. And are you aware of that? No? You just-
I may have heard about that. A couple of DOTs were working on that, but I hadn't realized this
So,
DOT in particular.
yeah, I mean, we need to look at that and see if that is still available, that, you know, if that's something that we can't get out to the districts as too and tie that into your work.
Yes, certainly. I think too, if there's common platforms that the same data streams can go through, then there would be some wins there. But I also realize within a research context, sometimes it's good to use individual isolated systems, one that measures a certain type of data point, but another that does the plow cams, just to prove the concept, and then understand a lot more how to best integrate that all into a common system. Thank you so much.
Thank you, Ken. So just to talk about CocoRa's a little more that he mentioned, that is sort of crowdsourcing, but it's extremely subjective. So that's where people can put a little weather station at their house. My dad is very active in this. He's a weatherman all his own. And of course, I have my own station that I must also put up at my home. But that's residential usually, but you could put it anywhere. I mean, we could have them at our facilities if we wanted to. But again, that's just another thing that he wanted to add to his list. So we have another couple of projects, and the next one's about advanced geotechnical methods. And I think you're going to enjoy this one. It's another very in-depth project, also of the EDC initiative. And here's Mohsen Shahandashti with University of Texas at Arlington.
Good afternoon. We did, this is yet another another EDC 5 related project. We are investigating the potential of using geophysical methods for advanced geotechnical studies. I'm going to talk about the schedule, where we are, a little bit about what they did so far, and then the future plan that they have. We started the project early summer. We are in early stages of the project. We did an overview analysis of existing geophysical methods and their potential for geotechnical studies. And we started implementing one of those that we think has the highest potential for application here in diverse soil development issues. why we do that. Resistivity, yeah, it's better. It's awkward though to have a microphone in front of you. For resistivity imaging, what we get from that study is resistivity, electrical resistivity. This is not geotechnical characteristics, it's not PI of the soil, but in our districts we are interested in those sort of things, the plasticity index of our soil. So what is the relationship between those characteristics of the soil and the resistivity data that we get in order to come up with those and create those associations especially crafted for Texas? We are doing these laboratory tests. We are doing physical properties tests and even soil mineralogy tests in order to create those associations that after doing the resistivity imaging in the field, we can go back to our office, and using those relationships, we can tell what we have subsurface. We are especially interested in order to connect what we get on the job site in terms of resistivity with the characteristics of the soil. So we want to connect resistivity with the characteristics of the soil, including dry unit with a specific gravity and so on and so forth. These are statistical models that we are creating and we already created, includes the multiple linear regression models, especially crafted for the case of Texas. It is among the first studies that it is focusing on Texas and soils, collecting the data and creating these association basically rules. In this study, with the help of research team, we selected 5 districts to focus on. In this study, we are focusing on Paris districts, Fort Worth district, Beaumont districts, Lubbock, and El Paso district. The reason that we are focusing on these 5 is we had probably 2-3 meetings along with a lot of emails passed around the research team, communicated with each other to select that. It was difficult to select 5 because we couldn't go more than that. We had limitation on budget, but we still wanted to cover diverse soil conditions that we have in Texas, and believe me, we have really diverse soil conditions in Texas. And climate is different in Texas. We wanted to capture that as well. And also we wanted to have at least one district which is in urban area. So we selected one of them. So we considered a variety of basically criteria, including these 4 that I put here, starting with geotechnical properties, and selected these 5 districts. 2 of these districts, Fort Worth and Beaumont district, we already went to the site. We collected samples and we did resistivity testing for them. For Paris district, we only did resistivity testing. We didn't collect soil samples. We haven't collected soil samples yet. For Lubbock and El Paso, we plan to do it in the next few months to go and visit there and collect data. As I mentioned, for Paris district, we did resistivity imaging for along one of the projects that they had along the US 82. And we had 2 lines of resistivity testing over there. Later I show the results that we get, some of the results that we got. For Fort Worth district, in 4 locations, we implemented resistivity imaging. We also collected data from those sites, and out of 4 sites we had 2 of them we analyzed the data already. For 2 of them we have yet to look at the data that we collected and analyze that. For Beaumont district, for 1 location we collected the data, soil samples, and also we conducted resistivity testing in the field. For Beaumont, this is for a pavement project. For Paris district was for a pavement project too. Next week, early next week, we are going back to Beaumont. They have a bridge project. It is interesting. So we are collecting for bridge project also, we are collecting samples. With bridge project, I can go deeper and have soil samples because they are doing drilling for that. so I can have deeper soil samples. And it helps me a lot in terms of creating those associations. This is the result of Paris district, what we collected. Here, I didn't have the chance to collect the soil samples. I'm going back there. But what I can see here is, you see the borehole over there, borehole P4, number 4, over there. That is the place that they collected the data. And I have access to geotechnical soil reporting that data. But when I look at this, is considering the values of resistivity data that we collected. I don't go in detail. But what I see is clay soil. But another thing that I see, and in the soil report I don't see, is a huge variation of water content. That is continuously, I can track it and see it in this figure. It is shown with different colors. The red color is showing higher resistivity. As we go down in that scale, on the right, we have lower resistivities. In the places that I have high resistivity, those are dry clays that they have higher resistivities. So I see huge variation in the water content in that area. This is the data we collected from Beaumont district. This was a pavement project. The location of P1 is where they had boreholes over there. We have access to that data. Interesting thing about this is along that, in 2 lines, we also collected the resistivity imaging data to see what we have in terms of the soil. As we see, it is over there for 1 point only, they have the data. I have for the continuous image of what's under the, basically, under the surface in 2 lines. The line, the photo on the top, the figure on the top, the image on the top over there, is for the line which is closer to the highway. It is interesting, the variation of the same thing here, the variation of water content is hugely different between these 2 lines. The line which is closer to the highway, we have red surfaces close to the red areas close to the surface. That is because of the shrinkage that we have, shrinkage cracks that we have. Through those shrinkage cracks, I have areas that they got very dry, and you can see it in the, I have clays that they are very dry, and you can see it over there. But the one which is farther from the highway, it has less fissures, less cracks. It is interesting. I'm doing now another project, implementation project with TxDOT, which is about slope repair management. Over there, it is the topic is different, but it is interesting that these results and this method can be used for monitoring of the slopes, because I can go to the slopes, implement it, and see where I have, how much cracks I have, and what is the condition of that slope that I have. If the slope condition, if it is critical, I can do a more detailed analysis of those slopes. This is something that it was not part of this project, but it just came to my mind, which is showing the high potential of application areas that this project could have. This is Fort Worth District, one of the areas that in Fort Worth District we did this study. The red areas over here, the scale is not the same. So red in this image is not the same as the red in the other images. In the other images, it was red was about 50. Over here, the red areas are about 150 ohms. They're showing resistivity. In these areas, the soil is changing in the red areas. I have sand over there, for example, which is completely agrees with what we found in the boreholes. The BH2 is the borehole that we had over there. And in the borehole, you see that we had sand on the top and clay on the bottom in that borehole. The resistivity show exactly the same area. The area which is red, the resistivity of that is 150. It cannot be clay. It should be something else, which is shown here. One interesting thing is the boreholes. I cannot have boreholes everywhere, right? It's not, I'm not necessarily saying that we need to get rid of all boreholes that we have on the projects, but look at how much more data I can get if I implement it along with those methods, even if we don't implement it alone. Just to show you a little bit about the amount of data that I'm collecting. The orange points here are the points in the this is Paris district, by the way. They had a borehole over there, and for that borehole in 2 locations, I think it is 4 and 8 feet, I get the water content. They're shown here with orange, basically points. In that point, I can get continuous profile of the water content, as you see here. Not only in that point I can get the continuous profile of the water content, along the way that I collected the data, I can show you the water content of that. And this accuracy is pretty high because I had the chance to check it. And we are creating those associations, those regression data models for Texas. So this was pretty accurate what I found. Just to give you a sense of what kind of models we are creating behind the scene in order to associate the resistivity with the geotechnical studies. This is an example of those. For clay soil, for example, we created this. This is based on the data we collected from Beaumont District, Fort Worth District, and previous to this study, we also had the data for Dallas District. We had a project with them. So we combined all of them together, and we came up with these models showing the relationship between electrical resistivity with moisture content, dry unit weight, and plasticity index. What we are doing now is we are implementing this geophysical method on proposed projects. We plan to implement it by proposed projects by El Paso, Lubbock, and Paris District. For Paris District, is scheduled for 2-3 months from now that we are going, as they are doing drilling for a bridge, we are going and collect the data. For El Paso, I talked with them. They have some highway projects. I'm interested in pavement projects. I'm interested in bridge projects because I can get more data. So probably it might be a little bit delayed. Otherwise, I could collect data now even for that. Lubbock District, we have not scheduled the data collection yet, but we are going to do that in the rest of probably this month. We would suggest instructions to interpret the profiles that you saw, what I saw, then using those instructions, anyone can see what I just showed you, that what I see in those profiles, we are going to document it, how it can be interpreted, along with the other data you have. We create correlations. You saw one sample of that we created using the data we had. We are going to create more of them based on the data that we collect, and we prepare a manual. That manual will be, we are creating that by August, probably 1 year after the project. This project is a 2-year project. The reason I'm rushing through this project is this, because I want to have that manual as soon as possible. Because then for 1 year, I want to go district to district and showcase it to districts and how they can use it. And then I go back and make the manual better. If it is not something that they would like to see, I'm going to change it. This back and forth process will be continued as long as needed until districts, the engineers in the districts feel comfortable with what we provide in terms of the manual. Thank you.
Yes, I have questions.
Please.
A few of them. One, I'm gonna dumb it down to my level. Why do we care about the soil characteristics? What does that mean to us in terms of engineering?
Because our designs are dependent on that. If it is a highway project, if it is a pavement project, we want to know what is actually behind that. And it is even beyond soil characteristics. It's something, and it's a very good question, because it's not just soil characteristics. It's even absent of soil is interesting for me. Those fissures, those sinkholes that we see over here, we are interested to know if we have those somewhere. We don't want to build a highway, then we have a sinkhole over there. So they are going to help us. Not that the boreholes don't help. It's a different case. The boreholes help, but at the location we have them, and how many of them can possibly we have. So with this, we can have a continuous profile, which is helpful. For the bridge project, the same thing, the abutment of them. We care where we put them, and we want to know what type of soil we have, what is the PI of soil over there, and even beyond what I showed here, we are testing. You've seen that beyond the characteristics of the soil, which is common that we are using, like PI and so on and so forth, the density of that. We are also doing some tests for sulfur content. We want to also know that one because it has some implications for our foundations that we put in the soil. So these are the reasons that we collect. And these applications are pretty important. As soon as I call a district, I have meetings, like on every week basis, I call districts in order to see what interesting projects they have. I try to have even diverse applications, not focus. If it was pavement, probably this side of the year I could collect all my data, because these are more common. I could collect more faster the data. But I'm going after bridges, and the variety of projects and application is important for me. When I call them, I ask them, where do you want me to implement it to the districts? Is there anything that you're interested to know? So it matters on that end what they really want.
Yeah,
Thank you.
and so that impacts your composition, the depth of the roadbed, the actual location. I guess at some point you could actually vary the composition and depth if we got really specific and didn't think the conditions would change over time. Is that fair?
If I understand well, yes, it is. I can re-implement this process wherever I want. So yes, the reason that we are going after diverse applications is to be able in the future to repeat this project for any other application. But that is a fair point, it's a good point. Is it repeatable? We do our best to the possible extent to do that. The reason we have diverse set of districts to implement it, one of the reasons is this, because we wanted to have diverse applications, diverse characteristics in order to be able to repeat this process. We want that manual to be something that the others, the other districts other than these 5 be able to use.
And your cross sections, were they lengthwise along basically the center line of the road, or do they reflect exactly where the centers are placed, or are you penetrating underneath the road in most cases? I know you did those 2 that were 15 and 20 meters away or yards.
It's a very good question because it goes back to how we implemented that. Actually, it varies. For the places that they already had pavement, so they wanted to have samples from pavement. So I couldn't do possibly resistivity imaging on the pavement. I could do that, but I wouldn't get good results. So I went like a few feet actually to the right of way, and I did it. For some places, we go there before even they start the construction. That is the case for Fort Worth District. That was one of the data that I showed you. One of the 4 locations was related to a slope project. We had the chance to collect the data before the project starts, so I could do it anywhere I wanted. So I did it exactly at the location that we were interested to have the data.
Are you finding that one image close to that center line of that section is sufficient to reflect the composition for the entire width of that road? Or if you were in a case where you were building a new road, would it be better to do images basically by lane? Would that make any difference?
We would like to recommend that we do it in several lanes. And what I didn't show you here, and later my plan is at least with one case study to show that I can have 3D image of the place, not 2D. If I collect enough data, I have a grid instead of a line, that I can create a 3D image of what we have underground. So my goal is have at least one case study to show the 3D image of that. But it is recommended. It depends on the type of the project, of course, that we have. If it is a highway project, it's different than a bridge project. But for a highway project, at least a couple of lines in order to capture the variability of soil. And it is interesting because I'm pretty sure in a lot of places probably they're seeing this, but in Texas, the soil type is rapidly changing. So in Paris district, along one highway, one side is one thing, the other side is another thing. So it it is an evidence for me, showing that I need to implement it for more than one line at least to capture that variability.
Just two more. Is parallel better than perpendicular to the road? Does that make any difference? Have you noticed, or have you even had a chance to test that?
We haven't tested that, but that's a good point. I will. For one of them that I had parallel to the road was I couldn't do it perpendicular to the road. Otherwise, I would have several of them. So I couldn't possibly do that. Otherwise, that would be my preference to do actually both. But now that you mentioned it, for the one that we are going to Beaumont District next week, I will ask the crew which is going there to do it one perpendicular two in the location that lets us do that. Next time I'm presenting here, I answer this question.
And is there a limit to the length that you can put the sensors out? I mean, obviously not physically, but is there degradation if you try to make the length too long to the accuracy of the resistance?
In fact, your intuition is right. It's a physical limitation for me, and depends on the instrument that we have. I have two types of instrument now, 28 and 56 electrodes, AGI instrument, SuperSting R8. For those, I cannot go beyond 56, basically electrodes. Say 2-3 feet apart, if I put them, guess what the limit is, and I cannot go beyond that now. But this limitation cannot be imposed on the manual because it depends on what instrument is bought, and I highly recommend to the districts to buy something that it's meeting their needs. But I'm limited with that. I prefer to have all of them installed because the reason for that is I can go with deeper depth, and I don't want the distance between two of my electrodes to be more than something, 2-3 feet. And the reason for that is I want to get a good, accurate data, especially at this stage that I am doing I'm establishing the relationships that hopefully for decades they will be used here. So at this stage, I don't want to sacrifice the accuracy to get more data. I want to get good quality data. For that reason, I'm not setting them with higher, basically, distance with each other.
Are you specking out that equipment already? I mean, to the degree where we could begin procuring it?
Yes, actually, we have specifications of that. One thing that I avoid in the manual is I don't write the provider of that, the name that this is the one, and I'm trying to be as general as possible. So I tell what should be bought with what degree of accuracy, and the rest is on the, and I have recommendations if someone comes to me, but I don't impose it on the manual that this should be done for the reasons you know better than me. But yes, I have a list of them, and they can be both. In one of my, this is not related to this research, but I'm building even that equipment because I don't want to be dependent on the supplier of that. So hopefully next year by this time I will even have my own equipment. It is not very sophisticated sensors, so I think I can do it.
And I mean, I know what the pictures tell me, but is the feedback from the real engineers coming back that, look, this is a major leap forward in the accuracy?
In terms of what we had in discussions, we didn't have, we had good, actually, discussions. The good thing is, for this project, especially at this stage, along with the resistivity imaging, I'm also collecting soil samples. So that is not something that everyone agree on that. That when we collect the soil samples and we test it and we show it to engineers, they say yes. So the place that I had sand, I had sand. We tested that, they tested that, we collected the data, their contractor collected the data in the Fort Worth, and we all agree upon that. So in terms of accuracy, we all agree. That is the good point. If I wanted to, if we had some relationship associations, if I wanted to use them, probably in a few months I could finish all the data collections. The hard part of this project is I want to do resistivity imaging at the very same time that we do the drilling on the projects. There are several reasons behind that. One of them is that these profiles that I showed you, by season, they are changing. Those fissures, those cracks that I showed you during basically the precipitation times, they are going to be filled with water. As soon as they are filled with water, their resistivity drops. So I need to know what type of season I have. I need to know at exactly the same time I need to collect the soil samples. Otherwise, the water content, for example, would not match.
Could this have potentially picked up karst formations on MOPAC?
This is interesting. This is one of the questions you asked, and I'm happy that now, previously I couldn't answer with this. We are tracking even the cracks. So karsts, if they are in my radar, the radar of the collection, they will be captured with some level of confidence that now I can tell you. This is the question you asked probably 3 months ago. It was here. Now I have data to back it up. At least in Beaumont District, we proved that we can even show that.
I just had a comment, Darren, on that. We got a project that we're going to talk about a little bit about the wrong way here a little bit later, but I did want to say the last meeting you had this topic said you had presented on this, and we took that, and we were looking, we've been searching, Austin's been searching forever for a park and ride site for express bus service on the south side, and we all know how sensitive that is, you know, with all the karst and the Edwards Aquifer. So we took that, and we had an opportunity area that we used this on. And, you know, you and I, we had a conversation afterwards. We went ahead and did it.
Very happy.
So a site that would have otherwise not been possible is now possible. We did that. We ran like 8 lines. It's very interesting. I saw a lot of the same 3D stuff that you were showing there. But you know, what it's going to be able to do, you know, is kind of a greenfield site, would also be able to lower the risk and the potential costs, and, you know, gives you better knowns for the bids. So just from our experience, it's got a whole bunch of benefits out there, and we plan to use that a whole lot more in our projects. So, but I just want to mention that these meetings have been fantastic for information. Every single one, we pick up one, we go out and use it, and hopefully we can report back, you know, in a year or so on how we use that, your technique and all that.
Oh, that is wonderful, and I'm very happy we talked about it. It's very interesting. What you're doing, and you did it for a parking lot, I believe, right?
Yeah, it's a park and ride. There's about 20 acres out there.
For example, for that parking ride, it was recommended, and probably you saw even 3D images, because you did it in 8 lines. So it depends on what type of project it is. It's a very good example of when you want to have a grid, not just a line for the data collection. But yeah. The least that we can have is we can see anomalies. This is the least we can have from this project. That if there is something, then we go and collect data, which is helping, hopefully helping us. Thank you.
I think it's helping.
Thank you.
Thank you, Mus. Okay, so that was a really informative presentation. And in case you're not aware, you know, it's pretty important, like you said, with bridge placement, you need to really understand that area. Sometimes they put in bridges, and without a full understanding of the field environment, you might misplace that bridge and it might wash away. There are things that have happened. My husband's a bridge inspector, and he shared me with me some horror stories about things like that. So it's valuable research. I'd like to introduce another researcher here. We've got Kevin Balke, and he's with TTI. He's going to talk to us today about the automated traffic signal performance measures. This is also part of the Everyday Counts. And so, if you'll help me, Kevin's going to come speak with us.
Let's see, how do I get rid of the...
Well, howdy, everybody. I appreciate the opportunity to come and talk to you today be talking a little bit about a project that we're working on automated traffic signal performance measures for TxDOT. I'm filling in for Srinivasa Sankari, who is the PI on this project, and I'm also on part of the research team that's dealing with this. So as Shelley mentioned, this is part of the Everyday Counts program, is automated traffic performance measures. It's part of the Everyday Count 4 program. And really what this is about a system that gets put into a traffic management center that collects high-resolution data, data from the detection systems, data from the traffic signals themselves on a tenth of a second basis, and uses that to generate performance measures that are related to how well that traffic signal is actually operating, and allows you to look at and adjust the timings and things like that on the fly to achieve better performance of your traffic signal systems. So this is somewhat a different type of approach that has been used from the past. In the past, we as traffic engineers would go out and we would routinely check our traffic signal timings every 3 to 5 years, or if we got a lot of complaints and things like that, that started a process about retiming. What this new automated traffic signal performance measures allows you to do is do kind of objective-based timings, where you look at your objectives as what it is that you're trying to accomplish at a particular intersection, collect this high-resolution data, deploy strategies and tactics, and then you can kind of do a continuous feedback, and you can constantly adjust your timings and things like that to improve the operations of the signal as it operates. So how will this project really look and help TxDOT? Well, TxDOT's got 25 different districts. They each have their own traffic signal systems. They all have different goals, different objectives that are out here. So what this does is allow a tool to be developed that goes in and looks at and monitors the performance of that traffic signal systems, and allows TxDOT to do things like prioritize the types of improvements that have to be done at an intersection, or looks at how do we improve operations, what kind of maintenance strategies do we need to put into place, how do we update and maintain our practices related to that. And it really gets at the core values of what TxDOT's all about, focusing on the customer by doing better timing of operations related to looking at things like delays and things like that, doing a better fostering the stewardship of the infrastructure. How do we get the most out of our traffic signal systems, and then obviously looking at optimizing system performance. So what are we doing as part of this project? We've got several things that we're going on. One is, first of all, actually, there's several different types of automated traffic signal performance metrics that are out there. You can get an open source tool that comes through the Everyday Count programs. There's vendors that are out there that are selling programs. There's traffic signal equipment manufacturers that have their own set of automated traffic signal performance measures. So which ones are right? Which ones are appropriate? Which ones are appropriate for the districts that are out there? How do you get all this data back and forth? So part of the process is, let's look at what these systems do, and let's try to catalog what's going on with the various types of performance measures that they generate. The other thing that we're looking at is all right, so TxDOT is interested in this as part of the Everyday Counts program. There's been a lot of agencies that have put these things in. Let's talk to them and let's figure out what they have done in terms of their deployments, and look to see from a statewide standpoint, how do they bring all this data from multiple locations, multiple districts, back to a single location and kind of do that processing. We also want to look at the performance measures themselves. How can the performance measures be used by the traffic signal operators to look at how do I fine-tune my timings at an intersection, but also from the decision maker standpoint, where you're looking at trying to prioritize your resources. Do I need to focus resources on upgrading my detection systems versus deploying, implementing new traffic signal controllers at an intersection? So, and then obviously the last thing we want to look at is what is the effectiveness of the performance measures? How do you use them to actually enhance performance at an intersection? So this project is a little bit different. Too, because we've got several things that are going on. We've been tasked to kind of help TxDOT come up with a systems requirements document that they can use to go out and procure these type systems. So we're looking at trying to help TxDOT develop those specifications that they can use to go out and do that actual procurement. Once that system is then procured and put together either through TxDOT or by a private entity, we're also tasked to come up with some guidelines to help the districts make sense of all this data that comes in. Millie was talking earlier about the volume of data that comes with crowdsourcing, right? And so you get the same kind of thing with traffic signal performance measures. You get a ton of data that comes in, and so you have to be able to organize it and make decisions off of it. And so one of our goals is to help TxDOT districts kind of figure out how to analyze that data and to prioritize the decision processes that they make. This is a brand new project. We've only been working on this project for a couple months now. And so what have we done so far? Well, the first thing is, like every good researcher does, is they start off with the literature and see what's been done. So there is a documentation out there that exists. There is an NCHRP project that deals specifically with management-based, performance-based management of traffic signal systems. It's really focused on how do you use these performance measures. And so we've started there as kind of our process. We've also gone through the process of looking at and conducted some preliminary assessments from the various TxDOT districts that have these systems in to kind of look to see what are they doing. So what do we learn through the process? Well, the NCHRP process has outlaid this kind of methodology that you can use to look at that. It's really looking at all the different types of performance measures that are out there, trying to marry them up with your objectives that you're trying to accomplish at an intersection. Look to see what kind of scale am I looking at? Am I looking at a corridor level? Am I looking at an individual intersection? Am I looking statewide? Look to see what kind of gaps I have in the technology. Then procure equipment that gets in, configure that equipment, install it, verify that it's working correctly, and then start collecting those performance measures, and then apply them back to the agency policies and practices. What do you do with that data once it gets collected, and how do you make decisions off of that data? So you have to also remember too that there's several things that are going. This is not just about a technology solution, right? You have two parts of the elements to this project. You have human capital. What do you do with the data? Who makes the decisions? Who needs to be making those decisions? What's kind of the appropriate level to kind of come in and looking at that, as well as what kind of systems and technologies that exist. What kind of communication systems do you have to have? What kind of data logging equipment and things like that. It really boils down to looking at who are the champions and how is this system really going to be put together and utilized. So what are some success stories that exist out there? Most everybody who's been participating in the Everyday Counts program knows about the Utah system. If you don't know about it, let me explain it a little bit to you. Utah DOT has put in a statewide system and has developed a statewide system that is basically an open source system that goes out and collects data from all their traffic signals over the state of Utah and brings them back to a central location and puts it into a management software. They've developed that software. They've made it available to you through an open source platform and through the Everyday Counts program. Some of the things that they report as being one of their benefits is the way that they actually use that data that gets collected. They have traffic engineers look at problem locations on a daily basis and make timing changes on a daily basis based upon what's happening with the data that they collect. And they've implemented this system pretty much for all their traffic signal systems that UDOT basically maintains throughout the state. Georgia is another state that has taken the big plunge and gone into looking at a statewide management system. They basically have about half of their traffic signals online and collect data for. They use theirs very similar to the way that UDOT does. They collect that data. They look on a daily basis. They have traffic engineers assigned specifically to look at this data as it comes in to identify problems and fix those problems on a daily basis right away before they get the complaints kind of coming in and analyzing the data. So that's two of the examples of the success stories of looking at automated traffic signals performance measures. That's statewide. Now, what has TxDOT done? TxDOT has actually put their toe into the water and looked at how to utilize this data. Through the Everyday Count program, they've put in kind of a server over at Traffic Operations and have started looking at how do we collect this data, how do we use this data, and things like that. Several of the districts have signal performance metric systems that they've put in as well. Some of them are private. and some of them come from the traffic signal equipment itself. They all have different architectures that are associated with it. They all require different communication systems that kind of come back into play. And so there's things that we have to look at and try to figure out, well, what is the best strategy moving forward for TxDOT if they wanted to implement this on a statewide basis. So, again, I mentioned this is just the very early stages of what's going on in this project. Some of our next steps are we're continuing to reach out to the districts and see where have they implemented these pilot studies in the past. We're also looking at various city organizations as well. The city of College Station has deployed a performance measures system. So we're looking at both districts and cities to see what's out there. Through this process, we're looking at and trying to understand if TxDOT wanted to go to a centralized type process, or is the centralized process the right way for TxDOT to go? What do the individual districts need? What does the division need? What do the decision makers need? And looking at those needs assessments and looking at the gaps that are there. We're also going to be looking at, in detail, 3 different types of automated performance, traffic signal performance metric systems that are out there. They all use different systems. They all have different hardware, different software capabilities. They all have different resources that are needed. We're looking at things like trying to assess the benefit cost of that based upon how the data moves around, what are the performance measures that are generated. And then we're looking at, well, if you have one that's put in, say in Houston, and you have one that's put in San Antonio, you have one that's put in Brownsville, how do they integrate? How do they talk to each other? If they've done by different vendors, how do we bring that data back so that you have one integrated system for the decision makers to kind of do the things that they need to do related to that. So with that, I'll be happy to answer any questions at this time.
I have a question. What cities and districts are starting to work together to bring some of their data together related to traffic signals?
Well, okay. So what cities and districts, right? So Houston has a system that they put into play.
The city or the district?
That's the district has looked to put in. It's a system that's a vendor-based system. Fort Worth District has put in several different ones, other agencies. I know the city of College Station have some. I think there's some up in the Dallas area. The cities up in the Dallas area are putting in. However, I don't know if anybody is really bringing everything back together to a single location, and that's part of our project, is to really see how do you do that? Does that make sense? How do you distribute that decision-making process? Because the districts need to have that data at their fingertips to make those day-to-day decisions about how to manage operations. Where the division may need it to make long-term policy decisions and look at resource allocations and things like that. So there's a whole host of needs that have to kind of go on and be figured out as we're going through that process.
So that you're figuring that out as you work through the process, because that's what we struggle with in our region. Is there's so many different signal systems, and then the districts have different signal systems than the cities have, and each city has their own. And how do we integrate that? Because we need to make it seamless to the users of our system, and it's hard to do with different systems.
Yeah, that's correct. Yep. Thank you.
Kevin, do you see any benefits, air quality benefits, by going through, implementing autonomous or automated traffic signals synchronization? Do you see any air quality emissions benefits by looking at that? Or
yeah, so that's a different question from the project that we're exploring here. I'll answer your question, and yes, I think there is some air quality benefits that gets done by doing automated performance measures. Automated vehicles and things like that. What this system would allow you to do is, perhaps if you had an air quality action day that you had to do something with, an alert day or something, or you knew those conditions were doing, you could potentially go in and look at, well, how much am I contributing to those air quality impacts that exist, and what can I do, what kind of strategy can I implement, and can I measure that result by doing that? So it is in a way, and I don't think anybody's done this yet, but by doing this, by setting up this system, it potentially allows TxDOT to be able to have that flexibility to do those types of adjustments, to change signal timing strategies and to measure the impact of those signal timing strategies for air quality benefits, for problems with incidents, or things like that.
That brings up, I have one more question. So are you allowing any of this data to be shared with those vehicles that have the countdown for when the signals turn red and green? Are you looking at that as part of this project?
We're not really looking at that as part of this project, right? So there are, one of the vendors that we put up there and one of the vendors we looked at, that's kind of their model for giving out that data and making that data available. That's kind of one of the side benefits to them for allowing for you installing their equipment into your cabinets, right? So they can sell that or use that for other applications, or city could do that as well as if they wanted to. That is not the focus of this particular project. It's really about how do we bring that data back together so that we can make those management decisions about how to operate our traffic signal systems better.
Are you looking at what type of platform might be best to do that, like a cloud-based platform or an individual-based? Because we struggle with that as well.
Yeah, and that's exactly one of the things that we're trying to do is this. Do we do a cloud-based? If we do a cloud-based, or if we do a centralized, what kind of communication, is it cellular or whatever, to bring all that data back to a central location. So yes, we are looking at that.
Thank you so much. In the interest of time, we're going to go ahead and take a brief break. We're going to try to come back by 2:35, and we're going to start with wrong way driving. I know that Kevin will still be here if you have more questions for him, and then if we have time at the end, we'll have an additional opportunity for discussion and questions. Thank you. There was a big play button. See, they just hit play. So you just go like that. So that's where we are now, is wrong way driving. But now we have to figure out how to transfer to her, which you're already ready. So I
Central Texas against wrong-way driving accidents. We've invested in a wrong-way driving detection. System on the new 45 Southwest Toll Road. With the new technology, we can actively monitor and detect a vehicle's
Is there a pointer or anything? Okay, I'll just.
let's go ahead and find our seats when you get a moment. It's a good time to move on. The thing about Austin is that traffic, and if you leave too late, you're going to be stuck in it for a while. But speaking of traffic, and we're going to start again in just one moment. When everyone's seated, we'll start with the wrong way driving presentation by Greg Mack. It looks like we can go ahead and get started. There's enough people back. So please help me welcome Greg Mack.
Hello. Hey, Greg, I'll just do a quick jump in here. Mike Halligenstein wanted to make sure that we, this project Greg's going to talk about, it's really one piece of our project that we're really, really proud about with the Central Texas Regional Mobility Authority. It's one that we've partnered with. It's been in the works for 30-plus years, 45 Southwest. Just opened this last June, and, it wouldn't happen without the partnership with TxDOT, Hays County, and Travis County. But it's finally open. It's made major benefits in traffic savings. It's through an environmental. Anybody knows that area in South Austin by Circle C, right there on the county line between Mopac and 1626. It made that connection. Highly, in a sense, environmental area, but we saw this presentation by, who was it, last year? Again, another example. John Giannotti from San Antonio and their wrong way driving program. So Mike was here at that session back last November, and he says, we got to do that, especially down here. It's in a rural area. It's a new connection. And so we did that, and we got it in place for the opening. Greg Mack was the guy in charge of that, and we wanted to put the state-of-the-art technology and put a program in place to move that whole thing forward. So again, this is another benefit. We want to say, Darren, again, the thanks to this whole program. We're picking up stuff left and right that are proven to be providing big benefits. Go ahead, take it away, Greg.
Thanks a lot. Yep, learning from others. This is what we did. We had a TTI hosted a wrong way seminar. We went to that. We heard from a lot of, San Antonio is a leader, and then some other states. And then from that, we got in touch with the vendors and actually implemented for 45 Southwest. All right, so a little bit about Central Texas Regional Mobility Authority, because it's a mouthful when you say it. We're a multimodal transportation agency created by the state in 2001. We operate in Travis and Williamson County. We have 3 appointed board members from Travis, 3 from Williamson, and then a chair that's appointed from the governor. In the Austin region, we operate these roadways, 183A, 290, SH71 toll, Mopac Express lanes, 45 Southwest, and 183 South. We've opened phase 1 of that roadway. Phase 2 is opening next year. And then currently under review, under planning, is 183 North Express lanes and then Mopac South Express lanes. All right, so I think everyone in here is familiar with the trends of wrong way driving. Wrong way crashes are horrific. They're usually very damaging, high fatality rates. They happen at night on the week, Thursday through Sunday, is the hot times. So, doing that, creating a detection system, alerting the drivers when they're going the wrong direction is what we're trying to accomplish by implementing this technology. And that's what we want to do. We want to detect. We're never going to prevent it, but at least we can detect it, notify, and that's notification of the driver and also notification of the traffic management centers, and then eventually law enforcement. We want to quantify, because you'll see from another presentation, the metrics on this is it's going to alert. We have to quantify and classify those alerts to see there's too much noise. I think that's been a common theme today. There's a lot of data out there. What is an actionable data item? And we want to enforce, and that's involving our law enforcement personnel. A little bit about the technology. I'm a technology guy, so you're going to hear a lot of tech stuff. I'll try to keep keep it normal. So the biggest thing with wrong way is to confirm the action, to confirm it. So you use two different technologies. You know, in our implementation, we learned, you know, we wanted the Cadillac system, we wanted the best. So we went with a radar sensor as well as a FLIR camera, a forward-looking infrared camera, to confirm the wrong way movement before we light up the signs. And it's a, let me see if I get this right, red flashing rectangular sign. You'll see it later. And then we'll capture the images. We'll capture an image of the car itself. And that will be part of our alert system, as we can show the wrong way movement, show the car. And so here's some zones that we use. You know, the first is to actually activate. So we start lighting up the signs before we actually make the notification that is confirmed. And the hope there is that this correction zone is when the driver may actually turn around, you know, wake up, see the red flashing lights, and move and change their direction of movement. If they don't, the last thing is the confirmation zone. So that's when we get the alerts. We know they've had ample time to correct their action, and they've continued on the road. A little bit about 45 Southwest. It's around 8 miles from here. It made us that was a great candidate project for us because it's only 3.5 miles long. There's 4 access points, so it's easy for us to blanket that area with the wrong way system. So it's really contained within the wrong way technology that we can control the access points. And here's some of the metrics that we've had from the wrong way. We've only opened it June 1st. And I'll do a sales pitch for wrong way vendors is you think you don't have a problem. Like, this is a greenfield project. We didn't have a problem that we were trying to solve. We were trying to evaluate the technology. And we were like, well, you know, maybe this thing will go off once. But, you know, 6 months, it's gone off 56 times. And the classification of that is, the highest one is vehicle backup. And I'll show you the location that that's occurring in. We do have wrong way vehicles that we've confirmed after the quantify, like what happened to that wrong way vehicle. They pass that confirmation zone, but then we see them self-correct. They go over the median. We see them turn around at a later time in their travel. So maintenance vehicles, you're always going to have mowers and other activities that go up the wrong way of the exit ramp. False positives, so that was really happened at the beginning of our project. We since have tuned that out, working with our vendor, TAPCO. Emergency response vehicles, of course, you guys can go wherever you want. Pedestrian detection and vehicle made a crossing that actually triggered the event. Let's see if I know how to do this. All right, so here's the FLIR camera itself. This is on an exit ramp, and that's what the technology looks like when we see the inverse direction. That is another confirming thing that says, yep, we see a wrong way travel. This technology is really good at identifying the wrong way travel, and it's cut down on the false positives. And here's a location where this is at 1626 and 45 Southwest. These running little GIFs or GIFs, I never know how to say it, is showing some of the vehicle travel. So we have 2 sites. Let's see if I can showing up. I don't know. Okay. So one, we're seeing a bike going the wrong way, which is what you're going to have. You're going to detect things that does not need law enforcement to come out. That's just a bike driver. This other one, the top GIF, is actually showing a wrong way travel. This was actually Thanksgiving, and we see them make a median crossing later to correct their actions. This is the BlinkLink software. If you see the green on the border, that's the correct way of travel. The red is the wrong way. So it's another indication of like, hey, I'm sure that is not the correct way to move. This is Bliss Spiller Road. We're seeing a lot of this same movement. So you see the car go up the exit ramp. I mean, we have pavement markers there. We have red flashing lights, and they continue to make that movement. We were a little confused because we didn't understand why they were making that movement, especially this is in the middle of the day, so they should be able to see everything. We're finding that they're getting on the exit ramp and turning around going the correct way on 45 Southwest because there's not another entry point for their direction. So they're taking a risk. It is a low volume road, so they're taking the risk of going up the exit ramp to go the correct direction of travel. And then this is Archuleta is our site 4. We really thought this was going to be the site that really didn't have any wrong-way travel. Well, this seems to be the vehicle backup site where we are seeing people go the correct direction of travel, but then they have to back up because they missed their turn. So our engineers are working, and this is great because our engineers now get a positive feedback of what's wrong. What did we not sign that intersection correctly? Are we not putting pavement markers or illumination issue? Because a lot of this stuff is happening at 1 a.m. This is a normal visual that we see is at night they're doing a vehicle backup and then to correct their travel and to continue on to Mopac. It's also a new road, so a new direction, so we're thinking like, well, maybe there's an adjustment period where people don't know where this road heads. And then just to give you an idea of what happens when a driver sees, this is the point of view of the driver once you trigger the wrong way system. There's 4 poles that will give you lights, and if that doesn't wake you up, I don't know what will. And so from that, we're doing everything we can to say, you're going the wrong way, please turn around. Notifications after the system alerts, we get the email notification with 15 images associated with the wrong way travel. It gives you, location, timestamps, all that good stuff. And then actually, in the BlinkLake software, where we manage the event, we then an operator can then classify the direction of travel. We can see a little bit more video. We can see all the information that we got in the email, but then we can classify it post-event. And let's see if this works. I apologize to your ears. Yep. So at the Traffic Management Center, see if I can turn that off. Oh, that works. At the Traffic Management Center, they can also have BlinkLink up the whole time, and then that will actually alert the operator, hey, come look over at this system, something just occurred. So we have audio verification. And CTRMA, we have a Traffic Management Center. It's not manned 24/7, so our email distribution also includes TxDOT, CTEC, to help them manage the events when they happen at night, because most of these events do. There we go. Another thing we did with this system, TTI did some research about using connected vehicle technology in conjunction with wrong-way travel. So to actually hook up a roadside unit, this one's from Siemens, where if something alerts, the wrong-way system goes off, what I like to say is we're going to shout out that we know something went off, right? The cars aren't there yet. They're not, maybe 0.1% or something. But eventually the connected vehicles are coming. Ford made a commitment by 2022, all their vehicles are going to be connected. So we have to start getting ready for it. So wrong way application is a good one for that. It'll give 2 types of alerts. One to the wrong way car itself, saying you're going the wrong way. The other one to the other vehicle, saying wrong way driver ahead, watch out. So, in conjunction with the DMSs, you're also able to notify their onboard units of what you know about. You're an infrastructure manager, you know something's going on your road, and now you can alert the drivers inside the vehicle. So what's next for us? TTI is doing a study for us. I mean, this stuff is not cheap, and we can't put this everywhere, right? So we're going to try and make a data-driven decision and say, where should we put this? On our existing roads and our future roads. So they're studying our corridors now. They're looking at 911 data. They're looking at entertainment districts. They're looking at intersection design to say, like, if we're going to put some more technology out there, where should we put it? The other thing we're doing is public awareness. We're trying to say, like, hey, this occurs out there, and here's what you should look for. And I'm going to play a PSA that I think it might be the second audience to see. So. Yeah.
driving detection system on the new 45 Southwest Toll Road. With the new technology, we can actively monitor and detect a vehicle's wrong-way travel to help alert the driver while notifying the appropriate emergency response team, all to help maximize public safety and reduce emergency response times. Investing in technology for a safer Central Texas. We're the Central Texas Regional Mobility Authority.
I could have just played that video and didn't have to speak. So that kind of summarizes what, the technology is supposed to do. It's supposed to alert, and it's supposed to notify the driver. Some other proposed technologies we're looking at, we're always, we come to these events, we go to conferences, and we try to look for what else can we do. The wrong way detection system is this one. We're looking at the RSUs, the roadside units. We're installing those in some of our new roadways. And then, with the RSU, with the one we're picking, it also does the Wi-Fi and Bluetooth identification. So we're kind of getting a combo package. More CCTV cameras, more fixed cameras to do automatic incident detection with software. We do radar sensing units on almost all of our roadways. Dynamic message signs, roadway weather information. I know Ken spoke about, his mobile units. That sounds like a promising venture for us. Air quality and noise pollution, pedestrian safety, ALPR, automatic license plate recognition. We recently launched a program for habitual violators, people that don't pay your tolls. So if anyone has any unpaid tolls here, we'll find you. And so we've installed some of these cameras to automatically, once you're on the naughty list, it's Christmas time, we'll automatically identify the license plate and notify. We've contracted with some Travis and Williamson County constables. Will get their alert in their car, and they have the ability to pull you over. And then vehicle detection and classification. Right now, our system, our toll system, classifies with loops, and we're looking at overhead classification. So, our engineers hate it when we cut into the pavement. So we want to do overhead classification for the vehicles. That's it for me. You can find come up to me if you have any more questions or want some more information about our program. I have a card. You can also contact me through the website. And I'll open the floor to any questions.
I have a couple questions, and I apologize because my coworker, Tom Bamonte, had given me your contact information, so I should have gotten a hold of you before this meeting to ask a few. But one thing I had a question about, have you looked at, besides getting it into the vehicle, sending something through mobile devices like a reverse 911 type of notification if mobile devices are in the vicinity of that wrong-way driver?
Yeah, we looked at that. We didn't see any viable solutions. We asked our TAPCO, the vendor, and they haven't heard of anything yet. So if you know of anything, let us know.
I haven't necessarily, but it seems like it would be something that should be able to be done, but I don't know for sure how to do it. As well as like detection through mobile devices, because the connected vehicles are coming, but not all vehicles have that technology. But most people have smartphones, and so if there's a way that it gets to the level it needs to get at to detect that driver in the wrong direction on that facility through a mobile device, I think it has a lot of potential because it could be activated on all of our roadways versus just where that technology is deployed. And and that's what, we're trying to do some of that within the Dallas-Fort Worth region, although I know NTTA, our North Texas Tollway Authority, and our districts are looking at deploying this technology similar to what you guys have on your facility at spot locations.
Right. And with the mobile, what we've found, because we also operate MOPAC Express lanes, so it's one lane and 3 general purpose lanes. So we've always tried to figure out how can we differentiate our general purpose user from our express lane user. With GPS technology, what's our bubble? 16 feet. So it's hard to tell where the vehicle is per lane. Probably be easier to do the wrong way application because it's a little bit more separated. The direction of travel is a little bit more separated than 16 feet, but interesting.
The other thing that I think would be interesting to consider is when we work with the vehicle manufacturers, can we get to the point if somebody's detected going the wrong way, we actually stop their vehicle?
That's
Now,
where I think it's going.
yeah, I don't know if they'll allow that, but
You could do something to disable them, or can't even operate the motor vehicle if they're impaired. That would be great too.
yeah.
I think eventually this is coming. This is what we have now for technology that we can visual alert, but hopefully the cars won't even let you go the wrong way. You know, it knows the map of the roadway. I mean, the RSU, as soon as we pull up, I mean, it's giving you a high definition map of 45 Southwest. That's another, we're trying, as infrastructure manager, give you all the information to the vehicles that are listening. Here's what's here, here's what's coming up, here's a road closure or lane closure that we have planned, and let the car make some decisions.
And then I just had one more question. Mark and I were talking earlier before the meeting started. I don't know if anybody's using traffic signal detection technology to detect them going the wrong way on the frontage road before they actually get to the ramp. And so I would be interested to know if anybody's using that, because I guess it can be done. It can detect something going the wrong way, and if there's a way to notify them before they get on the higher speed facility, that would definitely be a benefit.
Yeah, they have to get here somehow, right? And usually they're coming from the arterials. We have this, we're struggling with other technologies. You know, we have the loop system, like I mentioned before, for vehicle classification to charge your toll. So it usually goes 1, 2, 3, you know, say 3 loops. We're trying to get a toll system to also be an extension of wrong way travel, where it says 3, 2, 1, well, that's going the wrong way. Let's use the tolling system, this technology we already had deployed to give us some help on alerting. The automatic incident detection, the cameras that we're looking at, also claim, you know, I always say this is a pilot. Some of this technology is good in a brochure, but in real world application, you don't know yet. They say they can do it with visual verification of wrong way travel. So we're going to prove that out once we implement that software.
Greg, I mean, the one other thing you may want to touch on is that, okay, this is our pilot locations, but where are you going to put the rest of them? And so we have a plan we've got a contract with TTI to help us plan that out. We're looking at 183 South and MOPAC. But, you know, coming up with a plan, working with TxDOT Austin District and City of Austin, it's going to be complicated for those frontage road type systems. Where's the best place to put them?
Right, TSMO. So with TSMO, we try to coordinate with the Austin District and as well as the City of Austin. MOPAC, we do have 911 call data that shows wrong way travel. We've seen them in our express lane. Well, if they're all the way in our express lane, they were going the wrong way a little bit before that, right? So then we don't operate those areas. So what can we do for our partners to help them implement wrong way technology? Is there hotspots that we can identify on MOPAC or even further in, you know, hey, 6th Street leads to MOPAC. So should that be a candidate location for wrong way detection?
Does the email go out to multiple police agencies, or is it sophisticated enough to know whose jurisdiction the incident's in?
So 3.5 mile road.
Okay.
3 jurisdictions. So yeah, I don't know if it's per site. Fabiola, our traffic manager, is here.
You can.
Yep.
You can assign.
So per site, we can identify different distribution groups. That's
Cool.
good, because that blew us away too. When we saw the lines, we're like, okay, 3 different responding agencies to this one little section of road.
And I'm not promoting this company, but to your question, I believe at least Enrix has recently offered a solution where they can geofence a section of road and send out mobile alerts.
And then also maybe Arlington, the Travel Safely app, I think might be another one to look at.
All right, that's my time. Thank you.
Thank you, Greg. Really appreciate that from Greg. So now we have 2 of our more popular projects that we're going to talk about really quick that have, they're RTI projects. They've kind of captured interest from a lot of different fields. So the first one is actually, it's traffic safety improvements at low water crossings. And Kevin is back. He's going to talk to us about that really quick. And it's very interesting. So if you have questions, I mean, I imagine you're going to have to ask him.
All right, so yes, I'm back. Okay, once again, thanks a bunch for having me and let me talk a little bit about this project. I'm actually the co-supervisor on this one. Kiara is the main project director for this, and she was unable to come. for this. This is a TxDOT research project through their traditional research program. And so we have a panel, we have a various representation from various districts throughout Texas, as well as a fairly large research team that's looking at this. So why is TxDOT interested in this issue? Well, one of the leading causes of death in the state of Texas is flood-related vehicles getting trapped in water, low water crossings. Most of you have heard this statistics before. It takes a very little amount of water to actually float a car to move it downstream. And so, that's 6 inches of water to lift up that car and get it moving, depending upon how quickly it's running. So there's one of the things that we're looking at in this project is a whole host of technologies and things that we can implement to improve traffic operations. Again, so one of the things that we're looking at is what can we do from a pavement marking standpoint? What types of pavement markings can we put out there to improve that? Is that including internally illuminated raised pavement markers or just standard pavement markers that are out there? What can we do from the striping standpoint? We're also looking at the various technologies that are there to detect when flood waters are crossing. Those of those who operate systems, you can buy a system now that does that. It's very expensive. And so we're trying to look at some of the cheaper type of technology that might exist and might do some similar types of things. We're also looking at, okay, if you buy these cheaper sensors, how do you tie it in with some of the active and passive systems that exist at an intersection? And so we're continuing to look at that. And then more specifically, getting into the connected vehicle world of things, we're looking at, well, okay, if you can get this data from the sensor, how do you get that into the individual vehicles and prevent them from going in? So we're trying to do a whole host of things, some of which are exploratory and some of which are more traditional types of means of doing things. So we have, again, a research project that has been going on. This project's been going on for about 1.5 years now, and so it's getting closer towards the end of its project. So we have a host of activities that are actually going on. Oh, I forgot to mention one of our partners here in this project is the Southwest Research Institute, particularly related to the connected vehicle side of things. I'm going to focus on the three activities that have been going on in this project. I believe we've already talked about some of these before in this committee. So we're going to talk primarily about what have we done in terms of the devices, what have we done in terms of the pavement markings, and then what are we doing in relationship to the connected vehicle side of things. So I'm going to start off talking about the pavement marking side. Our specific objectives in looking in this project, looking at this is how can we improve the visibility of markings, both in dry and flooded conditions, to help us try to figure out and to delineate what's happening at the various crossings. So we've come up with several different exploratory type of arrangements, anywhere from the traditional TxDOT and striping arrangements, things that are allowed through the MUTCD, versus some more advanced or innovative type solutions. And we've done some actual testing related to that, trying to evaluate how do they work both in day and night conditions, how do their performance vary when you start getting different depths of water. One of the things that we're worried about is being able to provide clear delineation through a very deep water, right? And you don't want that because it only takes that 6 inches to float that car. So we're looking at things like that. We're looking at things like, what impact does water clarity have? Water that is running down a low water crossing isn't necessarily clear. And so we try to vary, if you will, the clarity of the water. And then we've got multiple strategies that we're looking at: standard markings, wet pavement markings, raised pavement markers, internally illuminated pavement markers, and various things like that. So we had on 2 levels of testing out at our it's the Rellis campus now. Out at the Rellis campus, that tells you how old I am, right? I go back to the Riverside campus. At the Rellis campus, using some of the technologies that already exist here. We've done both daytime and nighttime conditions, and what we've done is set up a system where we've done some static testing, in doing some things where we can fill up the water tank, if you will, and look at the various levels, look at the very clarity of the water, and measure using a reflectometer, which is this device that's here in the upper corner there, and look at things like the pavement marking and what kind of reflectivity that you can from the various markers and the pavement markings that are going on there, and varying and looking to see what is the visibility distance. We've also constructed a low water crossing out at our Rellis campus where we've actually done some field testing, where we've gone in and instead of just looking at one or two devices, we lay out a system of devices and do it both in daytime and nighttime, looking at the visibility and how it changes. It's a little bit hard to see, but this is a crossing that is flooded. You have standard markings that go up to the crossing, and you go in through a water which obliterates the crossing and then picks it up on the other side. So we're looking at things like, how do you vary that? What does it change? What's the distance that you get in terms of the visibility that's associated with that? So in terms of findings, and you can read the slide as to what some of the findings are that are related to this, but what we've actually beginning to look at is in getting this notion of can we stripe the pavement markings in such a way so that if you start, we over-exaggerate, if you will, leading up to the crossing, and then if you can't see it going through the crossing, maybe that's enough to allow the motorist to say, well, they learned through experience that this is nothing that we should cross. So we're looking at both daytime and nighttime visibility. We're looking at both yellow and white. The other things I think is very interesting that these studies have looked at is the potential of using the internally illuminated raised pavement markers. So these are the ones that have the LEDs on them, that you see at pedestrian crossings and things like that, and trying to explore about how to use those in terms of crossings. I think there's some potential there that can exist both longitudinally and laterally across the crossing, right? Perhaps you could use red that gets triggered by a device that illuminates, kind of like at a crosswalk when you can't go through the crossing or shouldn't cross the crossing. So those are some things that they looked at in terms of that. One of the other things that we've looked at is what are the various sensors that exist out here, trying to look at it, trying to find one of those lower cost sensors, evaluate their effectiveness, kind of do some assessments of the benefit costs that are associated with that, and do some laboratory experiment. This was done by Dr. Hulabas with Texas A&M, and he's looked at various sensors that have been out there, different types of sensors, anywhere from sonic sensors to pressure sensors to radar sensors and things like that. And we've actually done field testing associated with that and measured the effectiveness of the various crossings, the pavement markings, the sensors, and set up different types of arrangements for measuring how well they did and measured things. We also looked at things like what kind of impact debris has on the sensor ability to sense water depths and stuff like that. And so there's a whole host of things that kind of went into looking at those types of sensors. Again, I won't go through the slide to let you know, so you can look at the various types of impacts that kind of came about related to that. But just know that different sensors have different effectiveness. The quality of the water, whether there's foam that exists at the water, things like the depth, all these sensors are kind of are effective in some cases and not effective in other cases. And so one of the things that we're trying to piece together is, okay, given that this is the way that these sensors work, where's the best place to kind of look to see and put those sensors in, and how do we actually do it to test them? The part that I'm working on really deals with this connected vehicle side of things. It really builds off of the same kind of things that we did with the wrong way driving project that was talked about earlier. And it uses trying to figure out, well, how do we disseminate this information about the crossings to the connected vehicles, knowing that connected vehicle technology is kind of coming along. We've looked at two different types of architectures. One that is a central-based type of architecture, very similar to what the wrong way driving project, where everything comes back to a central location and the information gets disseminated out to RSUs at roadside units, not just at the crossing, but further away from the crossing. And then we've also looked at and developed an architecture that says, let's decentralize the system. Let's distribute the intelligence out and put some at the actual individual crossings. So we have two different types of arrangements that we're doing some testing on and doing some development work on. So, and then the other important thing that we're doing as part of this is how do we integrate this with the sensor technologies that exist out there, and how do we make them work with the existing types of systems that are there. So this is the basic architecture. It's just a diagram that kind of shows what happens with that. roadside units are put in at the individual intersections. They collect information from the sensors that are there at the system. You can broadcast information about alerts, send out alerts at the crossing. You can send out warning information. And we're looking at two different types of warning informations, one when it's beginning to flood, and then one when you definitely don't want to cross. And how we do that through a traffic management center, and also distribute that information upstream. So part of the interesting part, at least for me, the interesting part related to this project is how do we actually disseminate that information? We're trying to use existing standards for doing that. For those of you who have been involved in connected vehicle type of arrangements know that there's a set of standards that exist that are produced by the Society of Automotive Engineers. It's the ones that relate to the dedicated short-range communications technologies. We're using a special message set that's associated with that, and building alerts that look very similar, if you will, to a way that a traffic management center would produce data and send out messages on a dynamic message sign. So there's some interchangeability, if you will, between the types of information that's there. So this next couple of slides kind of visualize how you would actually use that type of information. This is the way that the system would work is you've got a crossing. You can kind of see through the middle of this slide where this crossing is. You would identify that and build basically a geofence around that zone, around that center of that crossing. And so when a car entered into that area and was detected inside it detected itself inside of that area, it would then receive a message about what the status of the crossing was, whether you could drive through it, whether it's you're recommending not driving through it, and things like that. And so it's a very flexible type of system that's being put in and produced. All kind of standards based as we're moving forward with connected vehicle technologies. So where are we at with this system? Right, so all of the field testing has been done on the various pavement markings and the sensors. We're in the kind of doing the proof of concept testing related to the connected vehicle side of things. And then the next step is really to bundle all this together and build kind of a crossing, if you will, a model crossing, if you will, and try to look to see how collectively all these things kind of work together and their effectiveness. The goal eventually is to actually go out and do some testing at some low water crossings, put in various treatments, and let's evaluate their effectiveness over time and see how they perform over time. So with that, just kind of quickly be happy to answer any questions that you might have. One or two questions. Uh-oh. All right.
I'll make a comment.
Yeah.
Sorry. I think we need to, if you haven't already been in touch, there's an organization whose name has changed several. It was started out as Accelerate H2O, and I think it's Innovate H2O or something like that now. That's focused in the Houston and coastal region right now, but they've been working with LCRA to introduce sensors for flood management, but also for the issues as it relates to flooding on roads. And so if you're not already tied into it, then I think we need to get that done, because they're looking for these things and opportunities to do them.
I'm not plugged in with them. I'm going to make a note.
Okay.
This is somebody else's notes, but I'm going to put that down. Innovate H2O. Okay. All right. Any other questions? Thank you. I appreciate it.
Thanks again for your presentations. And now we have one more very important project. It's a research project that has been very important for the environmental division at TxDOT. They're excited about this project, and many of us are. It's the daily and seasonal movements of brown pelicans, and Andrew Burke from TTI is going to come talk to us about that. Welcome, Andrew.
Okay, well, good afternoon, and thanks for inviting me to this meeting. Today, I'm going to talk about a research project with TxDOT called, believe it or not, Daily and Seasonal Movements of brown pelican in the Bahia Grande Wetland Complex. So the first question is, why on earth are TxDOT interested in the daily and seasonal movements of brown pelicans? So this video is really showing why in a nutshell. This is a brown pelican attempting to cross State Highway SH 48 that links Brownsville to Port Isabel. You can see it's really struggling in headwinds. That's the number one thing to notice. It's going to cross the bridge and then slap bang on the road, where it's at the mercy of traffic. So that's just one pelican we're seeing there. On an evening with these weather conditions, when the pelicans are in the area, there might be 1,000 birds flying over this crossing in an evening, and under the right weather conditions, there have been 150, 200 birds have landed on the road, and up to 80 birds being killed in a single evening. And it's not nice. It's not nice to see, and it's not good for the environment or for the ecology of brown pelicans or the region as a whole. So this is where the problem is occurring. This is South Texas, Brownsville, Port Isabel. You can see there running through the middle of the screen on the left-hand panel, the Brownsville Ship Channel. There's the Bahia Grande Lagoon there, which is the big kind of inland lagoon, and just at the mouth of that, where it joins the ship channel, is the portion of the road, and it's a very localized portion of the road, which is experiencing the problems. And the problem is essentially the brown pelican landing on the road and being at the mercy of traffic. But there's other problems as well, which I'll get to. So that's our region. The bottom right-hand panel is showing a view of the road. It's a dual carriageway, as I'd call it, and with a central concrete traffic barrier 42 inches high, and then on the outer sides of it there's a 36-inch concrete traffic barrier that's protecting the vehicles from the lagoon, and on the other side there's not as much protection, there's not as much of a barrier, but there's intermittent barriers on the other side as well. So why is this a problem? Well, obviously pelicans on the road and being hit by traffic is not a good thing, but generally speaking, I think wildlife crossing problems tend to be complex problems. You know, there's the issue of conservation and the need to, the regulatory need to prevent wildlife crossing incidents. There's traveler safety on this road. There's vehicles traveling at 75 miles an hour and may be tempted to swerve and to miss pelicans. There's an animal welfare issue, irrespective of whether or not the species is endangered or of conservation importance. It is not nice to run over beasties on the road. And there's also, in this case, there's a public safety issue. Because these mortalities occur with cold fronts, people can see the cold fronts coming in, and there's this dedicated bunch of volunteers who actually come onto the roadside and looking to save the pelicans. And saving the pelican means they're there from whenever that cold front comes in to darkness, often in very windy conditions, rainy conditions often, and they're rushing into the road to try and basically catch these pelicans in nets and release them somewhere. So very, very, for me, a complex issue, not just about the fact that pelicans are falling on the road. This is what we think is happening from the perspective of just the isolated portion of the bridge, if you like, just from the road design perspective. And this image on the left is showing a cross-section of the road, so we'd be driving through the image. And on the left-hand side there, you've got the first concrete traffic barrier, and then you've got the medium one, and then you've got the outer concrete traffic barrier on the bridge. And basically, those traffic barriers with the infrastructure of the road, which is about 6 foot above the surrounding water line anyway, form a big bluff to the wind coming in from the left, and that's the pattern of wind that you see. So the blue wind, the blue lines are showing the direction of slow-moving air, and the yellowish and the reddish lines are showing the direction of fast-moving air. And they're essentially the problem for the pelicans is they're trying to fly through this. You saw the video of them trying to fly through strong winds anyway, and they're struggling even well away from the bridge. And then they come to this disturbed wind on the bridge, and actually as they're moving across that bridge, they're experiencing wind conditions that might be even faster than the ambient wind conditions around them, so they're either harder to fly through. So if they fly high, they've got the problem of faster wind, and if they fly low, they've got the problem of this wind stratifying, and they can stall and then just fall onto the road surface. So that's what we think is happening from a fine scale perspective. This diagram here is just showing what happens during a cold front and the prevailing wind conditions. And the top diagram is showing the wind speed from a local NOAA station, and then the blue, that's the red line, and then the blue and the green lines are showing the wind speed as measured on the bridge through a station we've installed there. And what's happening is for most, in this region, the prevailing winds are from the southeast. And so the day starts off for the pelicans with a nice gentle southeast breeze, and then the cold front comes in, and all of a sudden that wind switches. The middle panel is showing the wind direction from our weather station and from the NOAA. But the wind switches 180 degrees. Now it comes from the northwest. And that northwest wind there on that second right-hand panel is, you can see that's the direction of it relative to the bridge. So then when that wind shifts in a cold front and it becomes very, very strong, then it blows across that bridge and forms those wind effects that I showed you in the previous slide. And so another interesting thing about this is we installed the wind station, and we can actually see the stratification of the air from that wind station. We've got an upper anemometer with about 20 foot, and you can see there that upper anemometer is measuring about 10 or 20% higher wind speed under those storm conditions. So one of the things that we've got to do in this project to kind of fill in the pieces is we captured some pelicans and we installed these GPS devices on them. That's in the bottom right-hand panel. You can see a little self-contained solar-powered GPS device about as big as a Keurig coffee cup, and they're made specially for these pelicans, and we put them on a little harness with some ribbon. You can see the left-hand pelican there is actually, you can just see that's one that we've captured, and you can see the device on the pelican. And as the pelican moves around the place, that's beaming signals backwards and forwards to telephone masts and giving us information on their location and what they're doing. So I just want to show, just to kind of complete the story about why I think this research project is so important. I just want to kind of show some initial findings, if you like, or some hypotheses. Well, these red dots on the left are showing all of the places that are essentially roost sites for the pelicans. So these are the places where the pelicans are staying overnight. Essentially they're protected islands. They're islands, so they're a little bit protected from predation from mammalian predators. Now there's a bunch of other red dots all over the place, but essentially 80% of all overnight stays are in those two locations circled by squared by the yellow squares. And that is what we call the Laguna Madre roost site up there, and the one in the Bahia Grande right close to the road. You remember that's through the middle there is the Brownsville Ship Channel, and parallel to that is the SH-48. And then this is kind of just a big dump of all of the GPS movements that we've captured so far of 35 or so birds that we've found, that we've monitored. You can see those roost sites as the kind of the focal points of many trips, the beginning points and the end points of many trips. You can see also that there's a lot of activity south of that, south of the SH-48, which is lots of pelican activity as well up and down the ship channel. So for me, what this kind of essentially means, or occasionally as well, we've had birds that will fly 70 miles down to a similar laguna in Mexico and stay out there for 5 days before returning back. So, but most of the activity is just occurring within that 25 by 25 mile square, and it's occurring south and north of SH-48. So for me, what's happening, and you'll spot the error straight away on this map. I've got the arrow there of the southeast wind direction completely wrong. It should be down in the bottom right. But for me, what's happening is that the landscape of the Pelican could well be changing dramatically with the change in the wind. And the reason why I say this is, remember the Pelicans are starting out with a prevailing southeast wind coming from the bottom right up. It's not a very strong wind, and in the mornings they go out and they disperse across the landscape. They can use that beachfront there of Padre Island or all the way down to the Boca Chica. That's an amazing flyway for them. What happens is on an offshore wind, the wind hits the sand dunes, pushes up, and they've just got a cushion of air. And I've seen them fly down South Padre Beach in about two flaps. They go about 5 miles. Straight. So very easy way of moving around the landscape. But then a cold front comes in. The wind switches to the northwest there, and all of a sudden you've got all of these birds kind of trapped, if you like, on the south side of the SH-48, and they've got to find their way back. And this is, we're going to find their way back to the nearest roost ground, the one that they trust, in the Bahia Grande there. And this is essentially what's causing that conflict, I think, between the birds, the dispersal of the birds, and SH-48. And there's also, I think, a lot of activities going on along the ship channel, which also would require the birds to migrate, to move across the channel to get back to their roosting grounds at night. So that's my theory of what's happening from a landscape ecology point of view, a flight ecology point of view. If I was to summarize and sum up the whole problem so far from what we know, and there's more to know, but from so far, I would say the first thing is these cold fronts are bringing in some very, very, very strong winds that, irrespective of any transportation structure, anything else going on in the world, are very, very difficult for the birds to fly through. So that's the first thing. The next thing is I think we've established that the design, that's the barriers and the and kind of the juxtaposition of SH-48 causes additional difficult airflow for the pelicans to fly through. And so when they hit that, they've got a probability of becoming down and onto the roadway. The other one is, I think, that the Bahia Grande is just an important roost site for pelicans. And so therefore, they're always wanting to go to the Bahia Grande or to the Laguna Madre roost sites, and that brings them into conflict with the road. And finally, what we didn't know before this project is how important the ship channel, which again is on the south of the road, and the southern wetlands that from Boca Chica and down into Mexico, how important they are for feeding and loafing sites for these pelicans during the day. And again, it's an opportunity that brings them into conflict with the road. So we think we know all this, and we know a little bit about it. So what's the potential for mitigation? So one of the things that's currently being done is we've done some fluid dynamics models and testing of different barrier designs, which will take away some of that bluff of the concrete, of the 36-inch concrete barrier, and replace it with a railing type design. And we reckon that from the fluid dynamic work that might save us about 5 foot of bad air, crossing height, that might really be a big difference. It doesn't sound much, but it could be a really big difference between having 40, 80 birds fall in an evening to just having a couple. But that's taking place. But the other thing about mitigation, I would say, is these wildlife crossing problems, they're complex. They're complex both in the problem and in the solutions. And if we want good solutions, then what we have to do is we have to understand every piece of the problem. And so there's a wildlife problem. You know, what's the ecology of the organism under pressure? What's its behavior? There's a transportation problem. What road design, safety, traffic volumes, traffic speeds. And there's a societal problem. And that's conservation. Is it of conservation importance, or is it about people being on the road trying to save them? What is it about? What is it about this problem that makes it a problem? So all of these things make a wildlife crossing problem. And what I know is we're going to have more and more wildlife crossing problems in the future. And I'm just really grateful to TxDOT and the RTI program for kind of understanding how important it is to be able to mitigate this problem, to have the research funds available and to direct the research so that we can go through and explore each one of these pieces, see how they fit together, and then when we've done that, come up with, you know, some really good solutions for how to solve the problem. So I'd like to thank Chris Glancy, who's sat at the back there, my project manager, some guys from TxDOT EMB who are part of the team and just have a passion for solving these wildlife crossing problems. Robin Gelston, who's down in the TxDOT FAR district and is outstanding environmental coordinator, and then my two field workers who helped me collect this data. And I'll open it up to any questions. Yes, sir.
Any crash data attributed to the birds?
I've looked, but there's no reported crashes attributed to the birds. But as part of this research, we're actually looking at that interaction between the traffic volumes, the traffic speeds. The volunteers on the road are very adamant that the solution here is to reduce the speeds. I'm not sure it is, because you've got to spot the birds first anyway, right? So, and I don't know whether you saw from the video, this is happening on dark days, poor visibility, and when those birds come close to the roadway and in your vision, or you know, on the thing, they basically meld into the roadway. The brown pelicans are not, the gray pelicans are the same color as the roads. Lots of things there to explore, you know, that would really affect whether or not a proposed solution actually feasibly can work. Thank you.
Thank you, Andrew, for that enlightening project. And we have a couple more items on our agenda before we'll let you go for the day. If you have to go, I understand. You know, traffic is fun, but let's go ahead and hear from Brian Sims on the Local Technical Assistance Program. He's going to give us a summary of this past year.
Okay, good afternoon. I'm going to be very quick this afternoon. I think we're 35 minutes behind, so I'm going to try to catch us up a little bit. Forgive me, I've had some allergy problems today, so if I cannot finish this, Ms. Hinton, you will have to come up here and take this presentation for me. Dawn Hinton, Amelia Medford in the back of the room, and Deborah Dean, I think I see her. Thank you for coming in. Those ladies really manage and do the work that we're about to talk about. So just briefly, the LTAP program is a national program. It's a local technical assistance program. Every state has one. It was initiated through Federal Highway Administration. And I want to talk a little bit about the goals of the program as it relates to the Texas LTAP. It is funded mutually between Federal Highway and TxDOT RTI. So both of those organizations fund the program on an annual basis. We at the University of Texas at Arlington have had the opportunity to serve in a management capacity of that program for the last 4 years. Basically, we provide assistance to all 254 Texas counties. We provide instructor-led courses or classes, roadway-related courses and classes. Provide technical assistance when requested. We host a website to include a mobile website, develop instructional curriculum for highway and roadway courses, and then we produce a quarterly newsletter. From FY16 to 19, this is data of the counties that we have served and the instances we have served each of these counties across the state. So you can see some counties take advantage of the program much more than other counties do. We are actively, constantly pursuing every county within the state. And this next graph will give you a little bit of better idea of the counties we have actually reached and provided assistance to since the beginning that we've taken the program in 2016. So you can see we've still got some large areas that we need to reach out to. We're constantly reaching out to them. We just have not had a desire from that particular county to provide service at this time. Instructor-led courses, here's some of the courses that we offer. All of these courses are free, completely free to these counties and cities. And remember, it's local government, or if I haven't stated, it's local government that we're providing services to. So we're talking about county precincts, and we're talking about municipalities. You can see the various courses. In the year of FY19, we provided 128 courses to 2,309 participants in this particular area of safety. Infrastructure management, you can see some of the courses that are offered there in infrastructure management. And in FY19, we had provided 48 courses to 670 participants in these particular areas. And then one other area is workforce development. In 2019, we provided 84 courses to 640 participants for heavy equipment operator training. And this is one of our fairly popular courses that are requested. Technical assistance, we've had 49 instances from 2016 to 2019. Many of these would be an instance where someone would call it, it may be a drainage issue, culvert issue, it could be a roadway sloping issue, it could be a training issue. Have one of our technical or subject matter experts come and help develop specific training for problem areas that the county may have or the city may have. Special training events, we also have put on these particular special training events. Heavy equipment training for wildfires, heavy equipment rodeos are always popular, snow and ice control techniques, gravel roads academy, and then here recently, in the last few months, we've had a pavement recycling academy in Wise County up in Decatur, in Wise County just a few weeks ago. We did participate in, at the request of RTI and Federal Highway in the short course this year, in which we assisted in setting up booths for these particular EDC 4 and 5 innovations. So you can see there are 10 on the right-hand side. You can see there are 10 innovations that were focused on during that couple of days of October 15th and 16th. Many of you in the room are part of that, and we thank you for all the work that you did. We did have an estimated 560 attendees come into the booths and visit, predominantly TxDOT employees. But they came into the booths and talked to the SMEs, subject matter experts from Federal Highway. And then we had another 620 attendees attend the actual EDC presentations that were given by the Federal Highway subject matter experts during the short course. We've also hosted a regional LTAP meeting in March of 2019. You can see the states, ourselves and Oklahoma DOTs, or Texas DOT and Oklahoma DOTs were present. You can see the LTAPs that attended, Indiana, Louisiana, New Mexico, Michigan, Minnesota, Oklahoma, Texas, Wisconsin, and then we had 2 that came on online. We will be hosting in March of this year, of 2020, a regional LTAP meeting with the Great Lakes region and our region here. And we'll be doing that in Arlington, Texas. We also have a website up. On that website, there are various information that you can obtain. Obviously, our newsletters that we produce on a quarterly basis are all there. There's an equipment library checkout where there's loaner equipment that can be checked out. Also have a mobile website that you can go to, or individuals can go to and get information or videos, YouTube videos that we have put together for either heavy equipment, work zone, worker safety, and then there's other resources resources. Some of the lending equipment that we have in our office that we'll lend out at no cost to the county or to the city. And that's something that we push to have all participants take advantage of. Obviously, some of this is expensive equipment. Some of the smaller counties just cannot afford to purchase those. In 2018, our advisory board, these were the results that we had from our advisory board at the VG Young Conference in College Station. And you can see kind of the areas in which we were tasked with improving training, providing training for local government. Last, I want to speak very briefly to an initiative that we have in place right now. We all know that there are wonderful innovations, EDC innovations, and now there are 50 of them out there. The problem is getting that information out to local government. Most of the DOTs are obviously very aware of what these innovations are and have had the opportunities to go through them and have their experts look at what makes sense on a state highway, but the local folks have not had that resource in front of them. So what we're going to do and what we're in the process of doing now is developing a survey. It'll go through SurveyMonkey. It should be released in the month of probably January at this point, I would think. We'll have it out for about a month, and what the survey will do, we'll push it out to all of the 254 counties, all the precincts within the counties, all 1,016 of them, I guess. And then roughly 1,200 municipalities that we have identified. We've got partners we're working with the Texas Municipal League and Texas Association of Counties. We'll also ask for assistance from the MPOs and the COGS and everyone that can get that information out to local government. And what we're going to ask them to do is basically take that survey and rank, if they will, 1 through 5, give a ranking for each of these 50 EDCs so that we can get an idea of which of these EDCs are important to that geographic area of the state. Because we feel like that data is going to be very wide. We certainly know that in the rural areas it may be a roadway departure innovation that would be more important in crowdsourcing and maybe the metro areas or things of that nature. But we have not asked our constituents what is important to you. From that data, as we gather it, we're going to set that data aside in 2 banks, counties and municipalities. We think there's going to be some differences in opinions between a municipality and a county precinct, county entity. And then we're going to break it down into metro, urban, and rural districts. And we're going to basically get data, 6 sets of data on these two different entities, municipalities and counties. From that data, we hope to find trends and develop trends and training courses specific for that geographic area or that entity within that geographic area. At that point, we can then engage Federal Highway, subject matter experts to do training and assist us with training in those specific areas across the state. So we all know that what's good for some may not be good for others due to various things, whether it be their geographic location, the density of population, politics, whatever it may be of that particular area. So we hope to at least define what's important to each of these individual areas across the state. And from there, questions? Thank you.
I have a question, sorry. Here.
Yes, sir.
Have you considered integrating this EDC 4 or 5 in the different classes you guys doing for local government project qualifications or something? If there is like innovative financing or value capture to be integrated in that portion, because we have those classes statewide, and then the work zone traffic control where we can bring ITS or any innovation in this. Have you guys thought about integrating portion of this as part of the existing training classes?
Yes, absolutely. That would be the desire to do. Once we've identified what is important to these specific areas, then we would visit with Federal Highway, and we would take that existing training that is already put together, or presentations from those subject matter experts, and basically facilitate those meetings or those presentations in that area of the state. Thank you very much. Appreciate it.
Thank you, Brian. So we only have one more thing really on our agenda, and that's for Kirk Favre and I to go through the, stick and talk about the history. We're gonna make it brief, and then we would like some feedback from the committee members if possible after Kirk goes over his information. It's gonna be a little rushed, but those people that are here just to attend and watch, as far as for the committee questions, y'all can leave at that time. I mean, you can leave whenever you wish, but at that time you might not have as much interest in what we're discussing. So with that, please join me, Kirk.
Thank you, Shelley. In order to keep us on time, I think I'm going to forego going through the entire presentation that we put together and just give you the skinny on, the bottom line or the future of the stick. And right now, headquarters office is working to develop EDC 6, round 6, and they're looking at coming out with a series of regional conferences, regional workshops in the fall of 2020. And they're right now in November, December, January, they're going to plan to put out a call to the DOTs, local agencies, public industry, and et cetera, to provide feedback on a list of innovations that are going to go forward as part of EDC 6. So instead of 50, you'll probably see more like 60, I guess, et cetera, maybe 10 more. And some of these would probably be the same types of innovations you saw in EDC 5. But those are coming out, and we're going to keep you informed as those regional conferences come about. And from those regional conferences, we'll kind of scale down which ones are the best for the state of Texas. Just to give you some news, we did sign a new charter, and Darren and Al signed it back in November 20th, and the new charter is going to be available on the Tex LTAP website for the Tex Stick, and that kind of outlines our purpose, vision, and goals for the next 2 years, and it's also going to tell you, which the membership roster has changed a little bit, and so we've got the membership roster as part of that. Attachment A is part of the charter that we put together. So that charter has been signed. It's been instead of in progress, it's been completed. So it's done. The next thing I wanted to talk to you a little bit about is the future of the stick, and we've got a series of questions we wanted to ask you all, members of the stick, and we wanted to go to the very end. Yeah, there's a lot of complex graphics that were in here that would have bored you to death, I think, if we had to go through each one. But in the future, I think we're going to focus on the Texas LTAP program and try to get EDCs programmed and funding and training, tech transfer, and so forth with the LTAP program in the coming years ahead. So that's what we've come up with lately. That's the future look at the Texas stick. Okay, these are the questions. Okay, now we've got I'll let Shelley take over from here to talk to you a little bit about the polling, the poll everywhere that she set up.
First, let me say thank you to everyone who came to present today, if you're still here, and thank you, Kirk, for all the help in setting, these events up and assisting, and of course, Brian and his team. Don couldn't have done it without you. And so we have these. This is just a way to kind of help y'all to answer these questions. This is for the committee, and basically you can use. I can see some people are already entering it. So this is through Poll Everywhere and is directly set up through this PowerPoint. So all you have to do is go to, you need to go to your text, and then you want to send it to 22333, and then in your message, TXL, TAP, caps, doesn't matter. And then you can keep that open, and that's where you'll answer these questions. The first one is, where would you like to see the Texas Stick focus efforts in the future? You've seen a lot of the things that we've been doing, and we went over several of those today. And so now is a good just opportunity to give us some direction. And if you can, throw some comments in there, that would be great. This will be sort of recorded so that we'll have those answers and we can use that to maybe direct the next meeting and obviously efforts in the future. If you want to discuss it as well, we prefer to just talk about it rather than type it, that's okay as well. So probably allow a couple minutes for it to respond. So first, engaging other associations, I would agree with that. It's something we'll know for sure. And also I can invite Kevin Pete as the director of our research division to speak to these if he wishes to, you know, because you may know of something that we're already addressing. And then of course Brian. Okay, so does anyone want to elaborate on that? Like engaging other associations, meaning through, you mean other entities such as governments, local governments, public sector, what are we looking at? Okay, more innovative technologies. I agree, we could have a day of topics selected by members beforehand. We can do that and have more engagement with the agenda so that y'all can speak to what you want to hear about and we can get updates on those projects of interest or whatnot. We can do, yeah, making tech transfer easier. That's pretty important. That's honestly something that we're working on a daily basis with our new information technology division. So additional TSMO strategies, definitely. Implementing technologies and strategies with MPOs, I agree. And the value capture workshop we had the last 2 days, a lot of MPOs attended that. And it was interesting to hear their insights on that topic, you know, and other topics and their perspective on things. So I agree, if they were able to be a part of this or at least attend, that might be helpful. We can maybe add them to our list of people to notify about the meetings. And then if they were to eventually want to be more involved, they could be. Okay, so we're going to move on to the next question, but anything y'all put in there, my understanding is it will be recorded, right, Don? Oh, it doesn't. Okay, did anybody else have anything to add? Looks like everybody's mostly done typing. Just put up your hand if you're not done. Okay, here we go. Focus on, there we go, 2 of them. Continue presentations of proven successes. We heard today from CTRMA implementing what they learned here. That's true, and that's been very helpful, I would think. Focus on more projects and issues that have a direct impact on highway safety. I noticed that anything that did have an impact on highway safety drove a lot of questions, and, you know, for good reason. So we'll go on to the next one. What areas of interest, what are areas of interest we have not explored that may be beneficial? And you'll notice some of these questions might run together, but this is more of a one-word answer or brief that you can throw in there as far as like a topic area or subject matter area, something like that. Agreed, great. That's a big one. CAB, or CAB. Anyone else? Cav. No, that's all. It actually is very interesting, and we're having more and more projects related to that showing up. Wow. Okay. So the funny thing about this word cloud is that it doesn't put it all together, so you're welcome to speak up if you think that didn't convey what you would like. But yes, so linkages, demand, strategies, traffic reduction, I think, so maybe. Okay, unmanned aerial systems, yes, we could do that. There's definitely a lot of interest in all of those topics. Looks like everybody's, oh. Jeff, you got something? Anyone else? All right. It's hard to tell where that was. So, anything else y'all can think of? I can see air quality. That CAV and air quality obviously is linked a little bit, so we improve that over time with our practices of reducing vehicle emissions. So yeah, we can speak to any of those topics. So how can we more effectively relate EDC content to benefit other agencies? That might go back to the associations, but what are your thoughts on this? Is there something we can do to make that easier or to relate it better? Definitely workshops. Can better utilize the LTAP group. And we have mentioned that, and we will. We are every day utilizing them in a better way. Webinars. I agree, webinars are handy for our busy schedules when we can't really travel. Granted, we might not get full attention on those, but they're still very helpful. Executive summaries, that's good. Peer exchanges. We like the peer exchanges. As Darren mentioned earlier, we'll be looking into that for sure. I've already begun talking to Brian about that, or he started the conversation with me. Presentations of successful projects. The various size agencies, okay. I could see how that would be helpful, and if we bring them to the table, they can see more of what we're doing. Information sharing platform. That's true, we can definitely put out more information. Please take a look at our latest innovations, latest stick updates, cost savings. Okay, I'm gonna go ahead and move on. I know these are all great. Just hate keeping y'all so late. Okay. And then our final one would be, what resources should or could we provide to you all, STIC members, for you to successfully take STIC ideas back to your organizations? And we know that we've had some successes with CTRMA. I'm sure there might be other examples, and and there will be. Federal dollars. I knew that was going to come. I mean, there was no doubt. Did Darren do that? Briefing materials. Yes. Executive summaries or lessons learned. Yes, yes. That is innovation in itself, building on what others have learned, making it better. Got it. Executive summaries of projects, and we're working on that as well. I feel like since I've started, which has only been in August since I've started with research, they've already made improvements. Philip and Kevin are working towards that every day. Cost benefit, newsletters with summaries, that would be good. Peer exchange opportunities. Podcasts, I agree, especially when you're sitting in Austin traffic. You need something to listen to. Don't get me wrong, I love it. I moved back from Dallas to Austin just because I love Austin, and I'm willing to sit in the car if I leave too late. Before and after performance measures, yes. Facilitating the peer exchanges. I agree. And if any of you would like to make any closing remarks, or if you want to respond to any of these things that we've just seen, all of you are obviously welcome to speak. You can speak. You've got a lot of good things to say. Anyone?
Is that the last question up there?
Yeah, that
Okay.
actually is the last question. 184 of 184. We did good.
Well, I'll just say thank you for everyone's time, and thank you for bringing these to us. I mean, I know I ask a lot of questions, and I'll try to control myself. But I hope that these things excite people or get them thinking about other ideas, because that's what it does for me, and that's why I ask so many questions. So I think we'll take back all this feedback, we'll ruminate on it, and I think all of these were valuable input. And it's really what we need, because if anything I've learned through this and other task forces is the hardest challenge has been informing and getting to people. So, and yes, I'm wrapping up.
No, I'm not rushing.
No, there's the comment up there. So, thank you for your time and everyone's efforts. Yeah. Yeah.
We do that sometimes. It's okay. Y'all do it.
On behalf of the Federal Highway Administration, I just wanted to thank everybody for the last couple of days. We've taken a lot of effort to bring the value capture workshop here, and we had a really good, participation. And outcome, we're going to have some more materials that we can go out and educate the elected officials with. And today was an excellent stick exchange, and I just wanted to thank everybody for their participation in this effort. And hopefully it will continue in the next 2 to 3 years, and we'll make better progress on some of these initiatives and be able to report back our successes, especially our success stories. Thank you.
Agreed. And with that, I have maybe 2 more thank yous. Thank you to James Core for making the foundation of this. It was a very robust agenda, but I think we got a lot out of it. So thank you for that.